Yo, they said I sold out, hot jokes on you. My wallet's broke, but the globe came through. I ain't rich, I'm just rich in proof. Y'all still spinning circles trying to find the roof. I'm living rent-free all up in your head. If I make a post, y'all start seeing red. You brag, you gifted, you all so smart. World views held together with duct tape and farts. The yellies compromise while scratching their ass. Never left their mama's house, begging for cash. Say I fake Antarctica, bro, please hush. You ain't even been outside since Candy Crush. Under the bus, they roll me flat, but I bounce right up like who's laughing at that? You can keep your maps and your comment threads. I got photos, sunspots, and 310s in my bed. Under bus, they screaming shield, but if selling out paid out, I'd have paid my bills. Call me a traitor saying that I'm a fake. You have no map and no model, for fuck's sake. They said he's a Freemason, reptile clone. Bro, I can't even get a payday loan. I'm broke as hell and I rent my home. Lost my views, you lost your mind over a drone under the They threw me twice, but I'm still that dude who think precise. You can mean me, scream me, call me fake, but I'm the only one out here showing the way. They threw me under the bus, but I dusted off fine. I seen the South Sun circle, y'all still stuck online. 10 years deep, I questioned it all, but y'all can't admit we went over that wall. I packed my bags, hit the edge of the map. You stay home making memes and talking crap. You don't do research, you just parrot Dave and crude. And I tell you to never trust a dude. What? Saying he's a sellout, he's a shill, he's fake. Bro, your best researchers got stuck on Vape Gate. You think I'm compromised? Nah, I'm free. You're the one in chains, mentally. Dave White says, yeah, he must be compromised. He's got an app to sell, I'm sure he never tells lies. Didn't give a shit when he leaked my data on his app. He was probably on vacation, taking a nap. I took the L, learned, evolved. But y'all still mad, think the problem's unsolved. You don't need evidence, just vibes. Y'all think you can stop me from changing my mind. They can't face it, so they hate it. Truth's too heavy, so they fake it. I went south, they stayed blind. Now they rage online, stuck on rewind. They can't face it, so they hate it. They call it lies, so they can't debate it. They'd rather call me a lie than admit they're wrong. Cold mind's weak, but my will's still strong. I saw the ice, I saw the glow, the 24-hour sun put on a show. They call that fake, say it's CGI. Why thinks they can shoot a plasma ball up in the sky. I'm at the cold, I saw the stars opposite spin. They never left the house, they're trapped within. I found peace and evidence and proof. They found comfort in denial and goof. They yell, he's bought, he's part of the plan. But my bank says different, I'm still the same man. They call it selling out, nah, it's called growing. But your echo chamber won't allow you to be knowing. 10 years strong, I held the belief. Then I'm at the South Pole, brought me relief. Now they call me Judas, traitor, thief, but at least I left the code. Easy there, chief. Lad wants to see my ticket. Well, black and suck a dick. He's as dumb as rocks, and rocks had little pricks if they pranced around wearing robes. So scared of the truth became Antarctica phobes. They can't face it, so they hate it. Truth's too heavy, so they fake it. I went south, they stayed blind. Now they rage online, stuck on rewind. They can't face it, so they hate it. They call it lies, funny, I debate it. They'd rather call me a lie than admit they're wrong. Cold mind's weak, but my will's still strong. They call me traitor, apostate, fraud, but I saw the globe with my own damn eyes. God, they'll twist your words, edit your clips, lose another job and lose another relationship. They ain't signing tips for scared kids lost. Every fact to them feels like a cross. They don't want truth, they won't believe. Faith in fear, disguised as relief. But me, I took the heat, I took the fall. I faced the facts, I stood tall. Hey, I'd rather burn in your digital hell than lie to myself just to sell a sale. So keep my name in your live stream fights while I sleep comfy every fucking night. You can't undo what I've seen firsthand. Truth ain't flat, that's fact. It's a globe, my man, and I do it again just to prove what's real. Cause I don't kneel to your cultish feel. They can't face it, so they hate it. Truth's too heavy, so they fake it. I went south, they stayed blind. Now they rage online, stuck on rewind. They can't face it, so they hate it. They call it lies, funny, I debate it. They'd rather block me and mock me than admit they're wrong. You're limp and weak while I'm hard and strong. In law, now what's the end of the scene? That was the end of the song.
All right, welcome everybody to, I guess we're calling this a conversation, if you will. Does Flat Earth have anything left? Or is it done? I believe one of us believes that it is done, and one of us believes that it's still got legs and truth and facts and evidence and all that stuff. So we're going to find out tonight. Have a little conversation with my buddy Alan from Space Audits. It is episode number 1. It is November 12th if you're watching then. Sorry we're late, or I'm late. It's not Alan's fault. I was at a auction in Fresno, and it went longer than I thought, so I didn't get home till about 5. So 4 o'clock wasn't a good time to start. All right, let's bring him on, and we will get going. There we go. Oops, that's the wrong one. Get it right eventually here. And there we go. Boom. Alan, say hello, everybody. Tell them who you are, where they can find you, and all that good stuff.
Hello, everyone. I'm Alan from Space Audits and/or Ether Cosmology. We are one and the same, or synonymous, or whatever they say. So anyway, if you want to find our work and research, you can join our Discord at discord.gg/ethercosmology. That's ether with an A. And then my YouTube channel is at space_audits. So you can find our work there. We do weekly presentations on either flat Earth or ether dynamics.
Tremendous. All right. So I know we're just going to, basically shoot the shit, try not to have any kind of moderation that we don't need. So I believe I'll let you start if you want to do like an intro, or how do you want to do that?
Yeah.
Okay.
So since the TFE, we've all been searching for an answer, right? Like none of us expected, or some people did, but most of us did not expect to see a 24-hour sun. And it really made us, rethink the paradigm, go back to basics. And I wanted to kind of touch base and share some of the research and things that have come along the way and regarding celestial and terrestrial measurements, and actually the history of flat Earth as told to us from the Chinese perspective.
All right. Can I ask you 3 simple questions to start, just so I get a feel for where you're at as far as did we go to Antarctica?
Yeah, I'm fairly certain you guys went.
Okay.
I mean, that at all.
Yeah, no, it's just the main, the argument from most flat earthers is that we didn't even go. So that's a good start. And we did see the 24-hour sun. So you are of the belief that it takes place in the southern summer?
Yeah. And not only you guys, seeing it or whatever, but there's also record of the Chinese talking about it when they did their expedition in the 1400s.
Oh, wow.
And I also found some Greeks. It was I can't remember his name, Animaxines or something like that, Anaraxis or whatever. And
a bunch of X's and E's and S's.
Yeah, one of those names, So anyway, Anaraxines and Aristotle were getting into it, and Aristotle was like, "Well, what about the 24-hour sun in Antarctica, or in the southern half?" And he was like, "Well, I haven't seen it. I don't know if that's a real thing or not.
Right.
But if it was, he basically invoked like terrestrial features that surround the Earth that would like block the sun at different times of year, kind of thing." That was his explanation for it, but he didn't seem to bother him too much. But yeah, okay. The Chinese, which we'll get to in a bit, knew about it for sure.
So the first question was, did we go to Antarctica? You say yes. Is there a 24-hour sun? You say yes. Third question, do you believe that there's a South Pole that was 600 miles from where I was? Can we deduce that is in existence if we saw the South Celestial Pole? And we would have to assume what's underneath it. And we also know that people in different areas of the Earth can get there by all going towards the southern part of the sun. So do you believe that there is a South Pole?
Yeah, so I'm pretty sure there is. Like, it's just, you're just measuring latitude convergent lines, right? As they go together. Okay. You would presumably have the same thing in the north. Like how it works mechanistically, we'll talk about the mapping of the world using the stars versus what an observer, sees per their latitude. Because I think the difference is there. I think the difference there is that we see everything individually, but we're shown these 3D models that have a God's eye view that kind of give us an expectation of physicality to the heavens. And like, if this thing's over here, then nobody should see it over here. But the whole entire thing is absolutely designed from the top or from the bottom up as an observer-centric single observer to make the whole thing in both hemispheres. They used to have 2 separate star maps for the north and the south before they merged them together. But we can talk about that as we continue on.
Okay, yeah, I just wanted to make sure. And then, props to you versus many of the other flat earthers that won't even have me on their show or won't even have a conversation and block me, everything else. So I just want to give credit where credit's due. At least he's willing to come on, have a conversation, and admit what the truth is, which is, yes, we went to Antarctica. Yes, there is a 24-hour sun. And I guess by extension, I say there's a South Pole. And we'll get into that. But I just wanted to make sure that those 3 things were covered. So you can go ahead and begin whatever you want.
Give me 1 second. Let me just add something to the notes for circumpolar stuff so we can talk about that later. Circumpolar orbits and travel. Okay. Circumpolar longitudinal. Okay. So yeah, so to start us off, I wanted to talk about the celestial theodolite and kind of give an update on that.
Okay.
So recently, a member of our Discord named Brian did his extended the application of the celestial theodolite using eclipses, and basically the premise, which we'll watch a video here in a little bit whenever you're ready for it, but it goes over all the details and stuff. And I would also like to get as many globe lads to get eyes on it so that they can refute it or point out flaws in the logic and whatnot. So but anyway, the basic. Go ahead.
What's the deal with that guy Jesse? So I know that he said that he thinks that there's lies within there, or that the numbers are fudged, or that it doesn't actually do what you say it does. When you say you have you want to get as many Glober eyes on it, have you considered having him look at it if he thinks that there's some sort of lie involved?
Oh, dude, we've had endless back and forth with him, and he does not to get in. I'm not trying to slander him while he's not here or whatever, but to give you a truncated recap. He does things like conflate the analysis between the globe prediction for the observer and then for what we're doing. He calls it the same method. He built a simulator to cherry pick observations because, as we can get into it for the data, we're dealing with ratios of a triangle. There's should exist a location per each measurement where the globe would technically exist as for the measurement, right? And when we look into the data there, we can see exactly what he did, going to sea level and then finding the lowest possible hill to do the occlusion at. And we could see the difference in the numbers and what actually came out, because he went to a place where it's indistinguishable, not where it's one's better than the other. So a lot of what he does is try to conflate things and make it so that nobody can get a conclusion or understand anything.
Okay, so would you be open to a debate with him then over that? If we had on my channel or something? No. Okay.
No.
Because
you've been
through it a bunch of times?
We've been over it a bunch of times, and my last straw with that guy was the last self-theo that we did with him. He was asking for the equations that we were using for how we were doing our derivations. I gave him the equations. Mike gave him the equations. We sent him PDFs of the equations. This is all happening in the same exact time. He's screen sharing on Discord, so he has Notepad open. He's written down the equations that I give him, and he's in Discord telling people that I won't give him the equations. I'm not trying to deal with that. That's a level of
okay.
That's the equivalent of you didn't go to Antarctica.
I'd have to see what you're talking about. I mean, to me, if he's saying that it doesn't work like you say, or that it's cherry picked, or that, because I mean, really, what science is repeatable predictions, right? So the celestial theodolite should make better repeatable predictions than the globe, and I'm not sure it does that. From what I've heard, it's these couple times it works. Yeah, I'm not trying to take it away from you until you
no
present.
You're good, but there's a difference between that's not what I've heard versus I've looked at the data and I
True.
can confirm everything that's being said. That's an extremely important aspect of this whole thing, because a lot of people are relying on what that guy says and what Ruhiv says.
Well,
and they're not
true. I mean, but I'll say that
you're getting it through a filtered lens of,
I'll admit that,
what they want you to see about it.
Okay. And is the truth still that we are not including refraction in this?
We're not including refraction in it because the occlusion process is a physical process. So in other words, refracted light isn't going to intersect a refracted mountain, right? And I can show you some examples of what I mean by,
okay, I'll let you show me
by that not intersecting. So in other words, it requires the physical intersection between the source and whatever the mountain in this case. So what they'll try and do is they'll say, well, I want to add terrestrial refraction to the mountain because that'll make it match what the theodolite measures, but that doesn't cause an occlusion. That doesn't tell us anything about the occlusion. That just raises the apparent level of what it is, does nothing. And then on top of that, the astronomical refraction, the same situation. If it's refracted light, it's not going to get occluded through a refracted image, only when the source intersects, which you'll see as we go through.
Okay, and then so that video I saw from Goose, doesn't that show it that refraction does affect the view?
Yeah, that's our premise, that it affects it when the physical intersection occurs. Because what happens is it gets lifted up a little bit, and then the angle, which the physical thing that's emitting the light, has to be a little further behind the object before it actually gets occluded. So we're saying, when we're not accounting for refraction, we're saying that between you and the mountain, the refraction doesn't matter, because on the back end of the light that's coming from behind the mountain, when that stops coming to you, it's no longer being refracted over the mountain, right? Like that's the basic. When we say we're not accounting for refraction, that's what we're not accounting for. When the star is no longer visible, it's no longer refracted. And we just want to know where the light source of it was at the time that it was occluded. It's like it's almost so straightforward that it can only be only through like misrepresentation can it be confused.
Okay, well, I hope you're going to show us as because that doesn't make sense to me. I mean, anything that you're looking at and it gets blocked. I mean, it's just like the sun, right? You know, the sun is, well, again, I don't know if you believe that, but the sun is said to be below the horizon, and we still see it. So it's up above what's blocking it because of refraction.
Yeah, they certainly do say that.
Okay, you just disagree with that. Okay, got you.
Yeah. Just watching the sunset alone wouldn't tell you anything unique about the situation, because what they're saying is either true or there's just a lingering effect due to optics, and then as the sun goes away, it can't power through the atmosphere that it's that's between us and the light source. So
wait, so
either way, the
atmosphere has something to do with the sunset?
What's that?
Are you saying atmosphere has something to do with the sunset?
Yeah, there's light attenuation, like the makes an opaque layer.
But if atmosphere had anything to do with it, then we wouldn't be able to predict the time, because we wouldn't know the atmospheric conditions. So you would not know what the sunset. I can tell you what the sunset will be on Friday or next Monday or in 3 years.
Yeah, but you're basing all that off the apparent position anyway, which is predicated on knowing the atmospheric conditions anyway. So whatever it happens to be is however much refraction there happens to be. What I'm saying is either way it sets, just watching it set doesn't tell us anything unique about the situation. Because there could be, because like our premise is the sunset is an optical phenomenon, where you guys say it's a geometric phenomenon. Right. That's the big difference.
And if it can be timed, then which one would be true?
Nothing. Well, just watching the time of it setting doesn't tell us anything unique.
No, what I'm saying is tomorrow. So we know the sunset time tomorrow, right? But we don't know the atmospheric conditions. It has nothing to do with the sunset time. The sunset time is done geometrically, has nothing to do with the atmosphere. The atmosphere, if tomorrow ended up being a cloudy day, it's not going to change the time of the sunset.
Are you aware, though, that the whole model that's not predicted, it's post-dicted off of when the sun returns. So after you have enough data and you can say that, like, that's all it is. So what we're saying is that it's an optical phenomenon rather than a geometric, and just watching it and saying, but what about the prediction? It's a post-diction, so it literally can't tell us anything unique.
So give me another example of what an optical phenomenon is. What's an optical phenomenon? Just give me one, so that I can see if we're talking the same thing. Because you're making it sound like if it's an optical phenomenon, then it would be it would vary due to optics.
Okay. Yeah. So like you take the example of when a car is coming at you and it has two headlights, but when it gets further away, it just becomes one headlight.
Okay.
So like that's facilitated by an optical phenomenon. It doesn't have anything to do with curvature or anything like that.
And it has to do with the atmosphere, meaning that we couldn't predict the time that would happen because it would vary based on what the conditions were. But
okay, then just make it solely based on an optical phenomenon. That way, at the time's the same no matter what.
So I asked for an example of that.
Because the sunset, the same thing in question that you're invoking. Okay. That's why it can't tell us anything unique, Mike. That's why we need another variable. So, for instance, if you were to do a self-theo occlusion with the sun and a mountain or whatever, like you can make some determinations based off of the true position versus the apparent to see how much refraction and whatnot is actually affecting the stuff. But just watching it alone tells us nothing.
But predicting it. That's what I'm saying. I mean, if we're just watching it, you're right. But we predict it. We know what the sunset will be tomorrow, and it has to do with. You didn't,
though.
We didn't?
You didn't, though. No, it goes in a cycle, bro.
I know, but that's because it's time.
That's called a post-diction.
Sure.
If you know it's cyclical, and you know where its position's going to be, that's not a prediction. That's just a cycle and a post-diction.
Okay, so you're saying because it already happened, and then we are predicting it in the future, it's a post-diction, not a prediction. Okay, so we know what time the sun's going to rise tomorrow or set tomorrow because it's happened on that day of the year in the past, right? So you're saying because we know that, we can predict the future, and that's the only reason we can predict it. But if there's two models at play, flat Earth and globe Earth, and one of them describes why it is that we can predict that, and the other one says it's atmospheric, which can't be responsible for predicting it. So then wouldn't there be a clear winner there?
Well, like I just said, take out the atmospheric effect. If you're not accounting for it either, then we could just reduce it down to either optical or geometric. It doesn't matter. Like it's the same situation. Just
Okay.
watching it tells us nothing
Okay, go ahead.
about the truthfulness of either model. All right. Okay, so yeah, the goose video, though, that was illustrating that the differences in the occlusion time and how that would affect it. So what we're saying is that when the star gets blocked, whatever refraction was occurring, it can no longer overcome the mountain. Whatever refraction or optical or whatever is happening, it no longer overcomes the mountain. And we want to know where the true position of the star was with respect to the mountain peak at that time, because that's what is aligned for us with our field of vision. So we need to know, like if you think about that as the crosshair, like the mountain as a crosshair to the theodolite, so to speak, we want to know, or we go to the mountain peak to see where the stars align, to see if it's still aligned with our crosshair. That's all we're doing.
Okay. I guess where I'm confused is that, so then can't we just call what you're seeing in the celestial theodolite an optical effect that doesn't tell us anything about the shape of the Earth?
No, because there's a new variable there. There's an independent variable.
Of what?
So there's our distance relative to the control, which is the altitude of the mountain. So that's going to produce a unique angle, and that angle is going to be is dependent on the physical elevation of that mountain. So,
and where are you getting the information about what the angle should be? From Stellarium, right?
The elevation we're getting the elevation of where the mountain should be based off of like Wikipedia, like whatever the mountain source says. So Wikipedia, NOAA, any sort of reference that has the official numbers for the altitude of the peak.
Right, but where are you getting where the star should be in relation to that mountain?
Oh, yes. Yeah, from Stellarium.
Okay, which is globe-based, yes?
It's the nautical almanac that uses latitude and longitude, and all that is positions of the stars with respect to where they were at a specific time. So when we talked earlier, now the answer to your question, the quick, but yeah, it's a globe tool or whatever, that would be like the easy layup, right? Because it's a sphere, right? All it's doing is showing you where the stars are at for an observer at their latitude. So it's, again, when I was talking about that God's eye view perspective, that gives us that misconception, right? All we're looking at is where some dude took a zenith measurement of a star, and then 24 hours later, that star came back to that position. So we're looking at a series of the whole model being put together like that. It doesn't mean that the Earth is a globe. They do a geocentric transformation to the center radius of the globe, right? But we'll get into fictitious coordinate system transformation stuff if you want, to show that doesn't mean anything. So check this out. Even in if they're using a geocentric transformation, right? What they're doing is they're going to the center of the Earth, and they're saying, okay, you're in the center of the Earth. And then the actual surface of the Earth is a hollow sphere, and the celestial bodies are fixed on that, and they're rotating around you. But one observer only sees that one hemisphere at a time.
Right.
So when they go and they're not visible anymore, that's either due to them going on, due to the Earth being a ball, or it just being part of that same optical phenomenon we talked about, like a limit of vision. So if something goes so far away that you can't see it, that's our position. And we're saying that the way that it's mapped out, and especially with them using negative coordinates to describe things that are so-called below the horizon, there's no difference in mapping that out and merging it together. It doesn't mean anything.
Okay, so you talk about a limit of vision, but isn't it true that anybody anywhere on the Earth can always see half the stars, or thereabouts?
Yeah, that's exactly what I said.
Okay, so I'm just
in your field of vision, that's what you see celestially. So the celestial,
so you perfectly see half of a sphere in your vision.
Yep,
half of the stars. So how would that work on a flat plane? I mean, if I gave you a flat map and then I said put this dome over it so that the people see half the stars, kind of like in Shane's model, right? But the problem with it is there's a lot of other Earth there where there's more space there for people to see more than half the stars. On a globe, you can only see half. Are you sharing?
It works. Yeah. Oh, yeah. Sorry, real quick. Yeah, it works It works exactly like this. Right. Yeah, so you only see. So instead of seeing this out here like this, you see it only projected into your half where you're at.
Right, but I'm saying that is exactly half of the stars in that dome. But then other people all over the rest of the Earth also only see half.
It's latitude dependent and observer centric. It's the same thing as this right here. Check this out. let's see, Cell Theo, go over to here. So this is Shane's half projection hemisphere, right? Where Walter Bislin, whoever you want to say, or even the Chinese and Japanese, right? We have this hemisphere of vision. Well, this is the globe. This is the globe variant of it. Same exact situation, same thing. They're literally identical, and they all require that they're all observer centric.
Okay,
so that's why
one of them makes sense, because there's only half the stars are visible for that person on the globe. The other half of the stars are blocked by the globe. So there's no, the explanation from the flat Earth has to be distance related, that we can't see stars because of their distance, right? Or just it's magic. Because the globe has an actual reason. It actually explains, it actually describes. Whereas the flat Earth is just, believe us, bro, that light works this way. It puts the sun exactly where the globe model calls for it. It just seems to me like that's what it does. When you go back to Shane's model.
Yeah, okay. Listen, when everything arcs across your horizon the same exact way. Everything goes from the top right here, like at your zenith, and then as it gets further away, it gets lower in the horizon. That's true in both models as an optical phenomenon. It's just when you can't see it, you guys are like, well, that's because the globe is blocking the half.
Right.
We're just saying that's where the ground meets the sky, and that's as far as you can see.
Okay, so what about when, let's say, circumpolar stars in the south, those go around the pole star, that's their full night's travel, yet the star's on the complete other side of the Earth. Right, the southern stars are the outer edge of the sky dome. Right, the stars are, I mean, I could show you you can, that's not Shane's model that you can play with right now?
So there's two hemispheres of stars.
Right. So go is that okay? So go to that one and push the person out to like latitude 55. 55 south. Yeah. So go there. Okay. So let's say there. And then turn on the stars.
I don't know how.
They should be at the top. There's go up there. There's like a button that says stars. And you just have to like press a button or something that shows up. Stars. There they go. Okay, so now let's get a look at it. Wait, it moved you, huh? Go ahead and go back to where we were a second ago. I don't know why it's moving you. Latitude again, 55 or something. South. Okay, so see the red stars at the that go around Sigma Octantis? Okay, so if you play the time, pull the time forward a little bit just so we can see that in a day, those stars just circle. But those are actually the southern stars, which means half the night they're on the other side of the Earth. So if it's distance dependent, then we would be able to see Polaris, because how could we see stars further than Polaris? Because those red stars are not, the southern stars are the outer edge of the stars. There is no stars that stay and circle like they do in the north. So think about the circumpolar stars in the north, on a globe or on a flat Earth, they both work, because the stars never set, because they just stay right above the North Pole star. They stay right around it. They get orbited overnight. Okay, great. Now, if we go to the south, the same thing happens in the opposite direction. Yet you're telling me that the stars that we see are just, you said they basically rise and set. Everything's the same. Well, it's not the same, because those stars there on the globe are actually there. They actually just circle the South Pole star.
Yeah.
Whereas on your flat map, we have to pretend now that somehow those just manifest over there.
Yeah, I got you.
Okay.
So this is conflating the two things as like a God's eye view perspective. Nobody sees the full spectrum of the stars like that. It's
no, but I was down in the south and I saw the southern pole stars that just go around it.
Yeah. I don't disagree. That's a latitude dependent phenomenon in, like, as you're away from the equator in the south. The same thing happens in the north for the north lads.
But the north stars are actually there, right? The north stars are there.
And the southern stars aren't?
No, you just told me that those southern stars that just circle the dome there, you're saying that those are the outer edge of the stars, so they actually travel all the way to the other side of the Earth.
That's not what I said.
Okay.
I said that's a latitude. Seeing them and how you see them is latitude dependent, whether you're north or south of the equator.
I don't know what that means. Latitude dependent. Okay. Of course they're latitude dependent. I mean, what you're saying is that it depends on where you're standing, what we see in the sky. Yeah, no shit.
Right, but then you're turning around and saying that it doesn't matter and we should see Polaris from down here. That doesn't...
Because, so the stars that are in the south are the outer disk of the stars. The outer rim of the stars. That's the southern stars, right? Mm-hmm. Okay, so as the stars go around in one day and do a circle, those are the stars that you see go around Sigma Octantis. The ones that go all the way to the other side of the Earth. So when you see them up right next to the South Pole star, they're really on the other side of the Earth over by Australia, which is further than Polaris. So I don't get how we can say that it's just magically appearing there. I mean, that's why this is a stolen globe projection. And so, well, it is. I mean, the people in the South. Yeah. So do you know that that's exactly what you're supposed to see from the South according to the globe? That half hemisphere is exactly what the globe predicts. Exactly.
Did you know that it's also what a flat Earth predicts with two star fields?
Okay, but it's not what a flat Earth predicts, because a flat Earth tells me that those stars are on the other side of the Earth. That's what the flat Earth predicts. You just moved them. You just said that's what the flat Earth predicts, and then you moved it to where they're supposed to be, and you said, okay, that flat Earth predicted that. No, it didn't. You moved them there.
No, only when you're speaking through the God's eye view perspective. If we're talking the ground positions of the stars and what they're physically mapped to, they're separate for a reason. That's why they used to have two separate star fields. Merging the two with the fictitious observer in the center.
Yeah, they had two star fields because there's the north and the southern stars. Two different sets of stars.
And that phenomenon can't exist on flat Earth
because the southern stars go away from you all the way to the other side of the Earth, but I still see them in my dome sky. They still stay there, but they're the southern stars. In the north, it makes sense because they are there. The north stars are there. But in the south, if it's the outer disk, then play the stars that go around Sigma Octantis. I just don't know if people realize this. Go back to right there, and then just play the day of time of day. Is that day? Okay. So all those stars that are spinning above your head in the south are actually going around the Earth on the outskirts. They're not going around the pole star, or else they're going around the pole star of a globe. So you're saying that the southern stars in your mind are actually staying there and going around the South Pole? Because let me explain. If you're over in Australia, you see the same stars circling the same South Pole star. So they also have to see the same stars in their sky. And then so it's just everybody on the outskirts of the Earth sees the stars no matter where they're at on the outskirts on the other side. I mean, it just doesn't work. It just doesn't work.
So I don't know how it doesn't work, because the Chinese went and did the exact same thing. They mapped out the southern the exact same way they mapped out the south. What they did is they went to the Falkland Islands, they went to the star Canopus, and they got almost to the zenith. They had it at like 88 degrees under their zenith instead of 90. And then they mapped everything out with latitude dependent effects based off of that. And they used, hold on one second.
Yeah, but it's just when you keep saying latitude dependent, that's of course, everything is latitude dependent.
The single observer latitude dependency is key here.
But that's no matter what. That's no matter what. Who believes differently than that? Who believes it's not latitude dependent?
Because you keep conceptualizing it as a unified total model.
No, I'm saying
what an observer
I'm talking about what an observer sees. So do me a favor, grab the longitude and move the longitude and watch what happens. And tell me this is just by accident. Do you see that?
Mm-hmm.
So everybody on the outskirts of the Earth sees the pole star completely in an opposite direction. Notice those people see it over there, those people see it over there, but it's the same field of stars. So clearly there's a model that says there's a reason for that. And the reason for that is because you're at the bottom of a globe and you're all looking in the same direction to the South Pole. That's telling us that the South Pole star is in a different direction for everybody. So I mean, it's kind of now if you move the other way, move the latitude line and watch how it just unfolds perfectly. It's a sphere that unfolds. No, latitude. Sorry, that one. If you just kind of watch it roll, that's a sphere. It just works perfectly. That you have the North Pole star. And then as you go out towards the edge, now the South Pole star unrolls, and now we can see that in the sky. So it's just funny that I didn't know that you still think that it's this map. Because if we want to show something else, now go to is the sun on there?
What do you think this map is? This map is just the positions of the stars on the vernal equinox. That's all this map ever was, for two separate hemispheres, and then merged together mathematically. What these observers are seeing, they don't see it all at the same time. They all see it on the same latitude. So
yeah, they don't see it at the same time because it's time dependent. Yeah, it would be based on the time.
What I was saying though is that the Chinese went and mapped all this out as geocentric flat earthers using Canopus and then the southern Sigma Octantis, but there's two stars that lead it because Sigma Octantis isn't bright enough.
Right. So could they have been wrong?
no, hold on no, they were identical because later on we can get to an eclipse method that they use to come up with how to determine longitude, and it's identical to what's used today, like 1 to 1, like the accuracy. I'm pretty sure that the Jesuits took the Chinese model and then combined it mathematically, retold a whole story about how they needed to get a synchronized clock so that they could tell time at sea. The Chinese already did all of that in the early 1300s.
Can you turn on the paths real quick so we can see them? There's a button, I believe, to turn on the light paths.
You want to see some bendy light?
Yes.
Or whatever. I think is that right?
I don't remember where you do it. And then, do we see the sun or no? I can't really see the top of that. Where's the sun at right now? I don't know where the sun is. Do you have to turn it on up top or something?
All right, we're on star mode. There's no sun right now.
Okay, you can't. Let's bring the sun back just real quick so I can see. Okay, so that's the sun. Oh, it's kind of doing a video. So on the day that we saw the sun south of us in Antarctica, when it's actually over Australia, is there two suns? Or explain that to me, or what you feel now that you know that there is. You said earlier that you think there is a 24-hour sun. So people in Australia.
Yeah, we all see our own individual sun. All the stars are all individual to us relative to whatever latitude we're at. And I can show you that despite this projection in the globe saying that, well, the reason is that the sun is underneath you and all that because of the converging latitude lines, I can show you that over 7 million meters, the sun doesn't drop in elevation, the sun and the moon. Because like the big takeaway here, like forget about the socio-terrestrial measurements of mountains and stuff for a second, and like just observing the stars and where they're at and making a map based of it and having converging longitude lines and all that. Because like all that's going to work out mathematically per the hemisphere that it was mapped to. But when we introduce the physical occlusions, like what's blocking out the sun to create a shadow over the ground and create triangles with that per every observer at their location, what I can show you is that the sun and the moon do not change in elevation. So they're always parallel to the ground. That's the most significant thing put forward here, because all we're discussing is how apparent positions were mapped out. And to quote from Copernicus, if you're following what was conceived by astronomers for another purpose, i.e. conceptual models for ease of teaching, right, then you'll leave astronomy a bigger fool than what you're talking, or than when you entered. And what I'm proposing is unique because we're using the so-called light source of the object rather than the apparent position. So based on what the whole model is based on, it's not even based on the apparent positions that we see necessarily. It's based on the time that true position will come back in 24 hours. Because as these things get lower in the horizon, they end up lingering, and they don't follow the 15 degree per hour relationship at that. So everything is actually based off of where the light source is from the zenith measurement taken on the equinox, and then adding 15 degrees per hour to that. So we're interested in checking that to verify the actual altitude changes of these. Because if it turns out
you're breaking up. Hold up a second. Just you're roboting.
Oh, sorry.
Now you're frozen. Is it me or you? I'm running 5100 kbps. Am I right? So if we take a globe model, you can take Google Earth, for example. We can go anywhere on that model, and we can place an observer, and from there, the observation that the globe model calls for is what we see. There is no need to move the sun anywhere. There's no need to move the moon anywhere. It's just exactly where it would be on that model. Whereas on your model here, that's not the case. The case is no matter where we put the person, then they look up. Well, sometimes you have to completely move the sun from somewhere else on the Earth to inside that viewpoint for that person.
No.
Right?
No, we don't have to do that at all.
Okay, so
the observer, it's single observer built, man. And then what was the other thing you said real quick? Oh yeah, about the globe model. There's no globe model, bro. What you're looking at here are latitude and longitude.
Hold on a second. What do you mean there's no globe model? Go to Google Earth. That's a globe model.
Okay, and I'm going to explain to you what that's representing.
Okay,
right? That's put together from latitude and longitude lines. Latitude and longitude lines are just positions of where stars transited.
Yeah, but they exist on a globe. That's where they were drawn.
you're saying that they exist on a globe, but you can't know that just from the apparent position alone, just from mapping them off of a cyclical nature, just by mapping their apparent position. And when they come back, that doesn't tell you anything unique. That could go either way.
But there's a model that calls for that, and there's a model that needs a lot of help to get that.
These are the same thing. This isn't a model. This is a latitude and longitude coordinate system.
Okay, so put that. Go to 70 degrees. Go to 80 degrees south, and like minus 120 east or west, just so we can get kind of where Union Glacier is. Is it working there? Or I could bring it up too. I thought I wanted that little dome on there. I don't know why the dome disappeared. I'll see if I can bring it up here.
I'm not sure what happened either. Give me a second. Let me refresh. Yeah, there we go. It's back. It's back. I got it. I got you.
Okay. So, yes, thank you. Let me go in here. I gotta get back to the screen. I lost it. Where are you? Okay. So, and then, where are you at? I think you went 90 degrees. So go to 80 degrees just so we can get off the South Pole there. No, I'm sorry. Latitude 80. What is that doing?
Is that not latitude?
Okay, I guess so. I guess you're right there. Okay, I couldn't see it moving. All right, so there, and then put the sun, or put the date where it says day of the year. Put it like 3:55. One of those says day of the year. Do you see it? Like maybe go 3:55-ish. Okay, and then there's the sun. All right, so now put the sun at where it's off on top of Australia. Oh, I see. You're at the bottom of South Africa. Sorry, can you do the longitude? Move that for me just to Union Glacier, which is going to be like, yeah, take it the other way. No, the other way. There you go. Right around there. Back about 120. There. Good. Okay. So now take the sun over to where it's above Australia, which would be time of day. Is it there? Okay. So now the people in Australia see the sun above their head, and they're getting heat. It's heating them. Mm-hmm. And then the people in Union Glacier see the sun on the opposite wall. So there's two suns. Yeah. You're saying there's not two suns, or there is two suns? You're saying everybody has their own sun? There's an infinite suns?
Everyone sees their own individual sun that's latitude dependent. So what you're looking at is how you're going to perceive it in the southern hemisphere. It's going to do an Antarc for you as the true position of the sun circles above us parallel to the ground, as noted by the eclipse data.
Okay.
We'll get to.
So let's say it is parallel to the ground. That's fine. But I'm saying it's way over there. It's 30,000 miles behind me, but it just appears on that wall.
Oh, no, that's not fine. It refutes curvature conclusively, because there would be 4 million miles of curvature to that 7 million mile distance based off of an elevation of the sun being 6,731 meters high.
Wait, what?
Which... Yeah. Well, we haven't got to the...
So, but you're saying something moves parallel, but you mean it's moving level.
It's moving parallel to the ground, yes.
That's called level.
Sure, level to the ground.
Yeah, so that's a curved path.
What?
You understand the definition of level? Okay, dude. So level and horizontal now are the same word? So we can just replace one word with the other. They don't mean anything different?
So listen, when
I'm asking you, I asked a question. But I asked a question. Can we just call level things horizontal now and horizontal level? They're the same word? Because you just laughed because I said they're different.
Horizontal, straight, and level. Level doesn't mean curve. Level meaning curve is like redefined so that they could talk about.
So then you're saying that there's two words.
Respect your orthographic projections of an ellipsoid model and all that stuff.
No, it's just the definition of level. Level is from a certain point. So if you're saying level from the center of the Earth, then the oceans are level on a globe. That's how it works. You can laugh at it, but that's how it works. You have to admit that that's how they say it works.
That is exactly how they defined it. Well, what I'm talking about here, right? So do you understand that if Stellarium is a globe tool and all this stuff and all this globe stuff, that the elevation, the true positions have to actually change in elevation because the contour of the Earth is, we'll take the rotation example, right? The elevation change is physically being created because the curvature of Earth. Right. So the physical, the true position of the star would also have to change as well. That's what the whole model is predicated on. And when they say that when you're just standing, when there's an observer standing here and that star is setting into the horizon, they're saying that its true position, its true elevation is now at 1 degree. Now it's sub 1 degree. Sure. Now it's negative coordinates. Now it's under the ball. Right. What I can show you is that during an eclipse over the course of 7 million meters where there should be 4 million meters of curvature, there is none. There's a 10
Yeah, I don't even know what you're talking about.
there's a 10,000 meter deviation. That's it.
Okay, you'll have to show that. I have no idea I don't even know how far 10,000 meters is. 30,000 feet?
10,000 meters.
6 miles?
No, 10,000 meters is like 1,000 kilometers. So whatever 1,000 kilometers is in miles.
Oh, 10,000 meters, sorry. So wait, that's 30,000 feet. 30,000 feet, 6 miles.
Sorry, did I say 6 million meters or did I say 6?
I don't know. I got very confused with all these meters.
It's 6 million. 6 million meters comes out to
6 million. It seems a little high, though.
So in kilometers, though, that's just 6,000. So whatever the conversion is from thousands of kilometers to miles is what you would want.
I don't even give it what we're talking about there. I don't know how the eclipse has something to do with this model. Because it has to do with all models that use the latitude and longitude dependent, especially those in particular that say that the reason that the stars aren't visible is because the globe is blocking them because the physical elevation is changing. So where I'm confused is that if, let's say I'm in California and I say that the sun is a certain distance above my head, and then hours later, when it's above the head of somebody in wherever, Hawaii, it would be the same distance above their head. So I could see where you're just drawing that and saying, oh, look, it's a level, it's a flat line. It's flat the whole way. But yeah, because it's staying level, it's the same distance from the Earth no matter where it's at. I mean, not at the same time when it gets above their head versus above my head. Obviously, exactly. And we could plot out the whole thing and show that at no time is it ever going under anyone's head at any angle. That's the... Well, we see from a plane, you can see the sun below your eye line. When we get to, do you just want to watch the video real quick so we can? Yeah, we can. Let's get through that. You getting half of the argument is not okay. Doing any, yeah, I'll watch this video you want to watch, and we'll go from there. No, but I think it's a lot simpler than what we are talking about. But go ahead. Yeah, I'll watch this. Yeah, go ahead. Thank you. I appreciate it. All right, so I got it playing at 1.5 speed, so it's pretty normal speaking tone. It's pretty. Okay. It's not too fast. Now, that'll reduce the time to 13 minutes and 30 seconds, so we don't have to do the full 19. Tell everybody what we're watching, though, so that we can know what we're seeing. Okay, so what we're about to watch is a brief recap in the celestial theodolite and what we mean when the true elevation of the star is traveling parallel to the ground and it's not actually deviating like it should as per the globe requirements. So Brian gives a nice little recap on that and what the triangle situation is. And then what he's going to do is he's going to independently derive the altitude of the moon using the total length of the shadow produced during an eclipse. And then from that, he's going to derive the altitude of the sun based off of the occlusion from that. And then we're going to plot that out over all the observers for the 7 million meters that the shadow length was as the eclipse occurred. So as the eclipse occurs, we can, they should be changing in elevation, and what we're going to see is none. And he's going to go through how he did all of that and break it down. It's just pretty simple trig functions. And then if you have any questions during it, you can pause it, or just tell me when to pause and I can answer them. So just is your position though that we can tell the shape of the ground with lights in the sky, or we cannot? Because you've heard from other flat earthers we cannot. Yeah. So just watching the apparent position alone, nothing unique can be said. When you introduce occlusions, when you introduce terrestrial features like a mountain peak of a known elevation, you can start to make some determinations, because on a globe, the elevation of the mountain is going to be physically lower, which results in a different angle. And the whole system is derived from combining what we see with central angle theorem. So in other words, it's like, when, how you sometimes give the example of like, oh, well, the Earth's so big that, it just, like Home Depot type stuff, and the curvature, whatnot. Well, that's actually not true, because if at the distances that we're using for the cell Theo, what we found is that the description of how the stars move in the sky relative to an observer follows the full, like what we call the full celestial drop, which I'll show you some diagrams here in a second for the angles and all that. But half of that angle is what they call drop over distance, and it's always half. So in order for that to be true, there can't be, this mountain can't also be a flat earth prediction. You know what I mean? Like there's mandatorily going to be a different angle produced out of this, because the half of the curvature, the other half of it, if you double it, tells you where the star's at. That can't be true if it doesn't work that way. So the rationale of like
well, it's just a Home Depot situation is not true. There's absolutely a mathematical difference between the two, and especially because angles equal time in celestial navigation. The difference in angles
and
is
you
equal
think
to
that
time.
this actually is going to overtake things like the North Pole star moving 1 degree per 69 miles, something that's so simple that anybody can do, that anybody can verify, that everybody can prove for themselves. You think this method is going to overtake those things, or what? Because I don't see how you can think that the flat Earth is the truth, unless it's going to answer questions. It should be like things should be getting better because the flat Earth is coming out, right? Like if we should be improving on the globe's nonsense, and we should say no, the globe is nonsense. So the flat Earth, now that we know the Earth's flat, here's how we're going to repair and fix things that are a problem. But the globe Earth it answers all questions. Just by saying sphere, it answers the upside down moon, the upside down sun, the backwards moving sun and backwards moving moon, and the backwards setting right to left in the south and left to right in the north. Everything is answered one simple word, sphere. However, in this world, it's way more convoluted. Everything you just said right now is more confusing than I've ever heard anything on the globe. Ever.
Well, that's because you have a gross misunderstanding of the globe.
Well, how is it gross if I say we can place two people?
That's not my fault. Dude, your example was, how is this going to take over 69 miles per degree? Like, not even differentiating that we're talking a difference in true position versus apparent position.
Nothing. I'm saying
that we see the same thing.
Well, there's simple explanations. There's simple understandings when it comes to the globe. Example being that anybody can right now take their angle to Polaris, figure it out, okay, whatever that is, then drive 69 miles north, and the North Star will pop up by 1 degree. So you do that over and over again.
You could do that on a flat Earth too, dog. It's the same. Like, I don't.
What do you mean?
Your example is
what?
How
could you do that on a flat Earth?
Because we see in the same hemisphere of vision that the globe is using map as a sphere of a terrestrial sphere.
So it just happens to match then the 24901 globe.
Yep.
Okay. Well, hold on a second. Now, on a globe Earth, what is the circumference of the equator? 24901, right, or thereabouts. Mm-hmm. Okay. On a flat Earth, what is the distance of the equator?
Same exact distance. It's the same exact.
That's impossible.
Thing. And
it's impossible.
It's this. I know. And when you do the triangle thing and multiply
no triangle. What's the difference? What's the distance between the North Pole? What's the distance between the North Pole and the equator?
Show me the meme that you're talking about. It's the same as the radius of Earth.
There's no meme. I'm asking you what. Okay, North Pole to equator on the globe, I'll tell you, is 6,250 miles, 6,250. So
same exact distance.
Okay, then if it's the same exact distance, then that's the radius of a circle, and the radius of a circle at 2 pi r comes out to then the radius. Then it comes out to 39,000 miles. So the equator on the flat Earth is 39,000, not 24,901. So there's no way that your 1 degree per mile would work, because on the globe, that's 360 times 69 miles is exactly 24,901.
Yeah, that's a misapplication of the math, and I'll get the proper response for that here in a second.
Okay. So
we will definitely come back to that. Not running from it. I don't have the thing to address it, but I know exactly what you're talking about. That's why I said, because I've seen it in meme form, but it's not exactly correct.
Okay.
So we'll get to that. We'll get to that while or I'll look for that while we play this video. But yeah. So to reiterate, like, this is the difference in true position versus apparent, and this is why I'm saying this is why my position is that we all see our own individual lights relative to us in our own dome of vision, because what we're going to see here is that the elevation change that's required as per the physicality given to us through the model presented as the globe doesn't actually occur as it should. So here we go.
Yes, and you'll press play. Go ahead. I don't hear sound if you
should be now. You hear it now?
No. Did you hit with share? Share it with sound?
Oh, 1 second. Let me try again.
And then what I'll tell everybody is, after this video is done, I will look at super chats and answer those first batch, and then we'll go back to talking. So this way you don't have to wait till the very end. So just, in 13 minutes, we'll go over those. What happened to me?
I reshared it to see if I could get the audio. You're good.
No.
Let me know if you hear it.
We hear nothing. What do you have that playing on? Can you send it to me on Telegram and I'll play it over here?
Yeah, I certainly can. Let me send you the YouTube link.
And it might be the same thing that you can't hear, but I'm sure you've heard it before. Oh, you're going to send me YouTube?
Yeah. All right, here you go. When you screen share it, I'll be able to hear the audio and stuff play through. So just play it through, and I'll just watch it on through you, vicariously or whatever.
Okay. Let me find where you're at here. Red Allen, YouTube.
Hello, this is Amazing, and I'm going to
Can you hear
present
that or
a new
no?
application for the celestial theodolite.
Did you hear that, Alan, or no? You didn't hear it, Alan? Okay. Well, you said you heard the sound, so we'll be fine. It's just everybody can hear it. And you said put it at 1.5 speed. Is that correct? Is that what you said?
Yeah, sorry. Yeah,
okay.
Just play it at 1.5, and then let me know when you hit play, and I'll hit play on my end so we can watch to get there.
Let me get this. And we're just looking at that. Trying to see what this is on the whole screen. Okay. I see what's going on. Okay. Let me put this over here. Sorry, we got to fix this for you. I think that's the whole video. What is this thing over here? Calculate sun height? Oh, okay, that's from the video.
Today.
Okay.
But first, let's recap what it is for those who don't know. The celestial theodolite uses observations of stars setting behind mountain peaks. By noting the exact second where the star was no longer visible, you can then consult an astronomic almanac to determine the uncorrected angle to the star at the time, as in not influenced by refractive and other optical effects. By forming a right triangle at the base of the observed mountain with the other 2 points at the observer and the mountain peak, the geometric angle to the mountain can be easily calculated using basic trigonometry, where the angle is the arctangent of the height of the peak minus the height of the observer for this vertical distance divided by the ground distance, which is also going to be equal to the angle to the star from the almanac. It is interesting that the physical angle to the peak of the mountain comes out the same as the almanac angle to the star, despite there being no allowance for Earth curvature in the calculations. Most of the observations are done at long enough distances away that the amount of ground curvature would be significant. When the calculations are done using globe math, and that accounts for the curvature, the numbers are off by the amount of ground curvature present. Refraction, the bending of light due to the changing density of the atmosphere, has to be invoked to compensate for that difference, bringing it back to where it would be without the curvature. The following celestial theodolite measurements have been made to date, sorted by observation distance. The farthest one done so far has been to North Peak in Colorado, with a distance of 130,000 meters. But instead of discussing stars getting included behind mountain peaks today, let's try something new and completely shatter the current longest distance observation, which is going to be 7.7 million meters, which is 60 times the furthest record to date. And here's what we're discussing: solar eclipses. A total solar eclipse occurred on April 8th, 2024 in the United States, with totality lasting from 4:30 p.m. to 8 p.m. UTC time, and that was 4.5 minutes at any one given location. Noteworthy cities along the path are Austin, Texas, Dallas, Texas, Little Rock, Arkansas, Indianapolis, Indiana, Toledo, Ohio, and Rochester, New York. The path was going from the southwest to the northeast. And then, of course, the sun and moon are traveling from the east to the west. And the reason that the eclipse path travels from west to east is because the sun outpaces the moon, swinging the shadow around as it passes. The reason the path of the eclipse travels north is because the sun is getting farther away from the moon, making the angle of the shadow down to the ground more shallow and thus farther reaching. So now we've got to understand the eclipse. Where to begin? First, I want to understand why the path of the eclipse shadow would travel to the north. So the first thing to do is study the movement of the sun and moon in Stellarium, which is a planetarium app showing the position of the stars for a given location and time. Starting at the farthest point for the eclipse shadow, I drew a great circle route to the moon. Then at intervals of 1 nautical mile, which is 1/60th of a degree of longitude, I used Python to calculate the latitude and longitude coordinates for each of those interval points. I also recorded the observer's altitude angle to the sun and moon, which excludes refractive effects. And then I plotted the angle versus ground distance for both the sun and the moon. So starting here with the sun, the first step is to create a linear trend line of the plotted data, which you can see is this dashed blue line. And the R value is high, indicating it's a good match, or close to 1 rather. The slope of the trend line gives rise over run, so the slope value of -9 e to the -6 has units of degrees per meter. Vertical is degrees and the horizontal is millions of meters. When we take the inverse, 111,000 meters per degree, and then divide by 1852, which gives us 60.038 nautical miles per degree. This is close to the expected 60 nautical miles per degree, where the sun drops by 1 degree for every 1 degree of distance traveled. Going back to this 111,000 meters per degree number, if we multiply by 360 degrees to get the circumference, and then divide by 2 pi, we get the radius value of 6.3 million meters. This is close to the 6371 radius for the Earth value, which is what we'd expect. But now when we go to the moon, something interesting happens. If we generate the trend line like before, this gives us 9.13 e to the -6 degrees per meter. Invert to get 109,000, and then we divide by 1852, we get -59.1327 nautical miles per degree. Most unexpected. And then when you continue the math out, that results in a smaller radius value of 6.27 million meters. So putting this into perspective, when starting with the sun directly overhead and traveling 5,400 nautical miles, or 90 degrees longitude, the sun drops down to 0 degrees. For the moon, however, we only have to travel 5,300 nautical miles, which equates to 88.7 degrees longitude, for the moon to drop down to 0 degrees. Putting it another way, if we see the sun as if it is traveling along a celestial sphere with the radius of the Earth, then we see the moon traveling along a similarly slightly smaller celestial sphere. And that's what we're showing here with a side view of where the sun and moon appear as the observer increases the ground distance. So the scale is millions of meters in both directions. And with the sun, it's at the 6.3 million meters, the moon's 6.27. And then if we multiply by pi over 2, we get the base radius, which is 10 million meters for the sun and 9.8 million meters for the moon. So now that we have that background out of the way, we can actually analyze the data. And you can see here the path of the center of totality spanning across the US. And the data for the eclipse path is available as a Google Earth KML file from this NASA website. It tells us precisely where the center of the eclipse shadow is cast at a given time. There are 6,770 data points at 1 second intervals spanning from 6 p.m. to 7:45 p.m. for 112 total minutes. Next, the latitude-longitude coordinates for the ground positions of the sun and moon are needed over that time span. I wrote a Python script to extract this information using the AstroPy module. This allows us to calculate the distance along the ground from the observer at the eclipse shadow to both the sun and moon positions, giving us a base distance of our triangle. I also extracted the altitude measured in degrees of the sun and moon above the horizon for the observer, but these are for reference only. They represent an optical position in the sky, and we need to use the true physical position. The final measurement needed is the height of the object doing the including, which in this case is the height of the moon. What we're going to do is assume the moon is fixed at the 6.27 million meter height we found earlier, and assume it is only an optical effect that causes the apparent position of the moon to drop in the sky as we get farther and farther away from it. The following table summarizes the known and unknown parameters. So first we have the center of the eclipse shadow, latitude and longitude, which we got from the data file from NASA. Then comes the observer elevation height, where we can take those lat-long coordinates and upload them to gpsvisualizer.com, which will export a CSV with the elevation data. Then the sun and moon ground position, latitude and longitude, which is generated in Python. We have the ground distance from observer to sun and moon, which is calculated using Haversine from those latitude and longitude coordinates. The height of the sun and moon is what we looked at earlier, and we're going to assume a fixed height over the observation period of 112 minutes. There's the observer angle to the sun and moon, which is generated in Python, but we're not going to use it because it is the apparent position. And then finally, the physical occluded angle from observer to sun and moon, which we don't know, but we can solve using basic trigonometry. Our assumptions are as follows. Number one, the sun and moon are at different fixed heights as they travel east to west. We'll consider any change in height negligible over the 112-minute observation window. Number two, assume the physical positions of the sun and moon are in a direct alignment with the position of the observer. That is, drawing a straight line from the observer to the physical location of the sun is going to intersect the physical location of the moon. Third, the light from the sun to the moon, and likewise the shadow from the moon to the observer, is going to follow a straight path, where refractive effects of the light are negligible. Since we're using physical and not optical positions for the sun and moon, optical effects do not apply. And lastly, no corrections are going to be accounted for ground curvature. And here are the objectives of the analysis. Celestial theodolite calculations generally involve calculating the height of the mountain peak using a triangle of the physical geometry and then comparing to the known height in order to evaluate the measure of success.
Can you pause it real quick, Alan, just so I can ask a question?
Forces a different tactic for this analysis.
Yep.
In this case, over 6,000 data points are available to analyze, so instead...
just real quick, so how did you figure out the heights of the sun and moon?
Good question. So doing rise over run using the length of the shadow and then the angle that we have for the observer viewing the moon.
And you came up with 10 million meters?
Yep, the height of the celestial sphere.
Which is 62 something in miles?
Yep, comes out to be the same ratio as if you did 1/10 millionth of a terrestrial meridian or whatever. Like, so what that comes out, what that basically means is 6218 would be the if you did it in nautical miles, I think it is what it comes out to. So it all comes out to be the same thing. So like earlier when I was talking about how...
Okay, but if it's all the same thing, then don't we need to have the distance between the North Pole and the equator be 6250?
Yes.
Okay, that's what it is on the globe. But what...
That's what... Yeah, dude, the globe is just constructed from a symmetrical coordinate system with the positions of the stars.
Okay, but you know how a circle works. So let's not play dumb. You know how a circle works. hold on, let me just make sure, because you're making it sound like this is more difficult than it is. We know how a circle is, and we know how to get the circumference and the radius and everything from a circle. So if you think of the equator as a circle, the equator is a big circle. Okay, great. And the radius is going to be from the North Pole to that circle. So the radius of the flat Earth is 6250. So when you do 2 pi r, which is 6.28 times 6.28 times the 2 pi r's radius. Okay, so it's 6.28 times the 6250. Let me see what we get here, making sure I'm seeing this right. So if we go 6250 times 6.28, which is going to be the 2 pi.
Comes out to 39.
Right. So that's the equator. That's the equator distance.
Yeah, that's because you're looking at a flattened out graticule and doing that. What I'm saying is that if you take out the latitude lines and multiply them out from the equator to the North Pole, it comes out to be 6210. You do the same thing for the south, it comes out to be the exact same thing. It's
right.
A symmetrical it's a symmetrical coordinate system.
Or we live on a symmetrical land.
Yeah, well, if that were true, then there would be 4 million meters of deviation in the true positions of the sun and moon as this eclipse happens. Let's see what happens.
Wait, there'd be 4 meters in the difference of what?
There would be 4 million meters of change in elevation if what you're proposing about the ground being a globe is true. If it's not, then what's going to happen is these are going to travel parallel to the ground.
Okay, no but if somebody walked, then if that is the distance between the circumference of that circle is 39,250.
Jaron, we can it's calculated observer individual through the whole string. It never changes deviation based on the angle. It's always the same altitude. It makes congruent triangles, bro.
I don't know what you're saying there.
Well,
what I'm saying is something very simple. Anybody knows how to figure out a circle.
No, I get what you're saying, but also, right, there's going to be elevation change for these people. Regardless, one of these observers over the distance are going to start to show an elevation change when we calculate it out. The only way that wouldn't be the case is if they were just parallel to the sky the whole time.
All right, let's continue the video. He's going to get to that
because, he's setting the stage for how he's deriving everything. Because, like, to answer the question, how do you derive the altitude of the moon and the sun? Well, once we have the moon's altitude from the shadow length and the angle from the observers, what we can do is, because the occlusion happens, we can derive what it would be for the sun under the same thing, making a congruent triangle. So as he's about to get to that, to the juicy part here, he just had to lay the foundational groundwork.
Okay.
Success will be measured in regard to consistency across the full data set.
Press play whenever you're ready.
I want to see what somebody wrote here. It says, Jaron, pi needs to be 2 for a 24,901 mile equator and a 6210 rate. Okay, so pi is not 2. So, all right, here we go.
We don't know what the height should be, but can we consistently calculate the same height across all the data points? These 6,000 data points aren't simply a similar measurement taken over and over again. Since the sun and moon are moving in the opposite direction as the eclipse shadow, the distance is constantly increasing from 2.6 million meters to 7.7 million meters, which is an increase by a factor of 3. Likewise, the altitude angle from the observer to moon drastically changes as well, going from 70 degrees down to 19 degrees, a change of 51 degrees. And then the azimuth to the moon sweeps out 140 degrees, the observer latitude changes 30 degrees, and the observer longitude changes 60 degrees. The observer elevation is fairly consistent except for this mountain range over Mexico. So the key parameters vary quite a bit over the data set. Now let's get into the actual analysis. The first step is we're going to assume the height of the moon is fixed at the 6.27 million meters number we found in section 2. H moon equals 6.274 million meters. Step 2, calculate the occlusion angle using a right triangle where the base is equal to the ground distance from the observer to the moon and where the height is the moon height. So the occlusion angle becomes the arctangent of the height of the moon divided by the distance. Step 3, we're going to make another right triangle from the observer to the sun using the same occlusion angle from step 2. And since the solar...
Just real quick, I just want to make sure, is he going to cover then, it seems to me that if we now know the height of the sun and the height of the moon away from the Earth, then we can figure out whether or not it's supposed to change in angular size, right? So like, for instance...
No, man. Bro, apparent thing that we all see individually. It's like what we see is not going to follow the rules of like a physical object moving away from you. That's nothing to do with this. You're kind of deviating from the significance of the fact that there should be a physical elevation change if the Earth is a ball, but there's not.
Well, I just want to make sure that I know what. So we have to pretend that the sun and moon are not physical, that they are magical. But everything else that we see on the Earth, a truck, a car, a building, those are real items. That's what
Exactly.
Okay,
just like you have to believe that they're imaginarily changing physical elevation. Yeah, the exact same. Go ahead and press play.
In a solar eclipse, the sun and moon are lined up with each other to cast a shadow on the observer. We can assume the angle from the observer to the moon is the same as the angle from the observer to the sun. So now we're solving for the height of the sun, where our equation is height of the sun equals distance of the sun times tangent of that occlusion angle. And that's all there is to it. So now we just have to perform this calculation for all 6,700 data points, and then calculate average and standard deviation values. The average comes out to 6,374,000 meters, which is very close to the 6,371,000 for the Earth radius. And then the standard deviation comes out to 6,200 meters, which is less than 0.1% of the average, which indicates the data is highly consistent. This is showing the height of the sun plotted out for all 6,000 data points, and the result is very flat. This is versus time. We can also show it versus distance. And the key point to consider here is we're actually starting the eclipse here, and the distance gets smaller and then gets bigger, so it's actually going over itself exactly, and it's so perfect you can't see it. So if you're thinking the reason it looks so flat is because the amount of globe curvature at this scale is negligible, then let's take a look. It most definitely is significant. What you can see here is 4 million meters at the end, which would be very significant compared to the 6 million meters of the sun height. And since we didn't have to account for it in the calculations, that is very telling. And then lastly, let's look at the physical angle versus apparent angle. There's a discrepancy between the physical angle that we calculated and the observed angle given by stellarium, even when it does not include refraction corrections. This disparity is shown below, which increases the lower the angle gets, similar to what we saw with the profiles of the celestial sphere. The sun and moon appear to be lower than their true physical position on account of optical influences. Here we can see the physical location of the moon is at 40 degrees, but the apparent is at 20. So there's a pretty big disparity there. And here's a spreadsheet showing the data. You've got the eclipse path, the sun, latitude, longitude, and distance calculations. Same for the moon. And then here's where I calculated the sun height. So you can see there's just a lot of data points here. And then you've got the average and standard deviation. So in conclusion, the relationship between the sun and moon during the total solar eclipse can be modeled out with very basic trigonometry while maintaining good consistency for the duration of the event. It is not necessary to make any corrections for ground curvature, nor to correct for refractive events diverting the path of the sun's light. This study does demonstrate that there's a difference in the physical position of where the sun and moon actually are located versus the apparent position where we think that we are seeing them due to optical effects. Even the globe model agrees on this point. This raises the question, is the ground beneath our feet curving, or is it the sky that appears to curve due to the nature of how our eyes perceive it, notably with the same radius value at which the Earth supposedly curves? I leave it as an exercise to the viewer to draw their own conclusions, but this only scratches the surface, and there's so much more to explore. And then let's briefly go over some things I have here in the appendix.
I'm just going to rewind that part real quick. I just didn't understand what he said about one part of that. Something about the same radius or something.
Eyes perceive it, notably with the same radius value.
Yeah, so that 6218 value that we were talking about earlier, you derive that same thing off of the altitude of the moon and sun, the constancy of it.
6218, anyway. Right. So he's saying that is the same. Should I read that part again? Where did you say that? Okay. So it's how our eyes perceive it, notably with the same radius value at which the Earth supposedly curves. But the radius value of the Earth curving is 3959, not 6250.
Oh, that's in miles and what he's talking about is in kilometers. It's the same value, and then one might be in nautical miles versus statute miles, but what we're talking about is the exact same thing. It's identical.
Oh, it's so confusing. So you're talking about the 6250 he's been talking about the whole time is kilometers, not miles.
Yes, which comes out to 3959 for miles.
Okay.
At which the Earth supposedly curves. I leave it as an exercise.
All right, we've been doing everything in meters. Do we completely abandon the? Anyway,
don't do that. It's the only thing I know. So
it's a rough transition, but yeah. Anyway, whenever you're ready to continue,
to draw their own conclusions, but this only scratches the surface, and there's so much more to explore. And then let's briefly go over some things I have here in the appendix. So if you're wondering about moon height over time, here it is mapped out for 2 months, with the eclipse happening here at April 8th, and it is changing by about 10,000 meters over that duration. If we zoom into the period of the actual eclipse, you can see it's going from 535 to 570 So it's less than 40 meters change, so not very significant. And when I plug the numbers in with the varying moon height, the average number for the sun height only decreases by 1 meter, and the standard deviation decreases by 10 meters, so it's not that significant of a change.
Oh, pause for a second.
And then earlier we were talking about.
Oh, yeah, I misspoke. This is in miles. It's 6210 miles, and then 3959 miles for radius. My bad.
But it said at the same rate that the Earth is curving.
Yes.
So the Earth curves at radius.
Yeah. So let me. I sent you a GIF to look at that has like the math equivalent for what we're talking about for that.
Oh, on Telegram.
Yeah.
Okay.
About the 88.7 degree longitude change,
Yep.
the moon to
Sorry
go
about
directly overhead to drop down to 0 degrees. So here we have an observer directly under the moon at point A, and then at point B is that 88.7 degree longitude difference, showing what it would look like on the globe model. And since we have a right triangle here at point B, it's just a matter of taking the cosine of the adjacent divided by the hypotenuse. So you can see the math here, and it comes out to 275 million meters. Now we're told that the moon is 350 to 400 million meters here in this range, and what we're getting falls a bit short. And then lastly, you might be wondering how you could solve this same process on the globe, where you're solving for the sun height. And it's very similar, but you have different triangles. And then in this case, you're actually accounting for the Earth curvature. But the problem occurs when you have any triangle, the sum of its three sides has to equal 180 degrees exactly. And so if I assume the minimum distance to the moon of 350 million meters, what happens is this distance to the sun angle and the observer angle, those two alone add up to more than 180 degrees, so it's not possible to make a valid triangle, and it doesn't work. So I hope you enjoyed this presentation.
What happened
I'm sure
there
there'll be more
in the analysis was the difference between what stellarium shows in regards to how the sun and moon and the celestial bodies, follow that 69 mile per degree relationship. For the sun, it comes out to be so if you were standing at the equator at 0 degrees and you were looking out at the sun being at 89 degrees, it would almost be right at the horizon, right? And then the moon would be 88 point something degrees. And when you trig everything out, you get a distance based off of that, like a physical elevation for it. And what he's saying here is that the distance that he derives using, the stellarium and the occlusions, which is what the globe is supposed to be predicated on. And when you compare that to what they say the actual distance is for Kepler's laws in Newtonian dynamics, which is you can derive Newtonian from Kepler and vice versa. So they have to give the same physical distance. He's saying that those distances don't match up to make the congruent triangle to have the eclipse happen the way that we see it. It would be off by a little bit. Now, it's possible that they could introduce refraction to correct that or whatever a little bit, I suppose. But what he just pointed out there was the difference between the plane trig using celestial navigation tools versus comparing it to the physical distance that they know that the moon is because of Kepler's laws and Newtonian dynamics and all that.
Okay. And I'll just show what I was talking about real quick so we can move past that. So what I'm saying, and then I guess we'll read the super chats after, but I'm just pointing out that this here is a, let's go with a little bigger, this one.
Here's an easy one for you. I sent it to you on Telegram. You can see it. It's got all the math on it already.
Well, so here's the equator, right? And on a globe, we know that that's 24,901. But on this flat Earth, if we put it on a flat Earth, well, now the radius of that is 6,250, right? So, oops, sorry, it shouldn't be. Where's my dash? Turn that off. Okay, so that's 6,250. So then we can do the math on it. It comes out to 39,000. So I'm just saying that that's a problem because we can do. We know what the Great Circle Route is all around the Earth, meaning any place that you're at, it's 24,901 miles to get back to where you are. So you can go north because that's where our longitude lines are, which makes more sense to use those. So if you went north and south, then for every 69 miles, the sun, or you can use the pole stars, are going to move up by 1 degree. So then how could that be the same on a flat Earth if the distance is different? Clearly, going from the equator to the North Pole on a globe would be 6,250, right? But it's 24,901 as the radius.
The answer to your question is you have to know what the tool that you're looking at is representing. When the Gleason's map is flattening out curved lines, they make them straight. That's it's still representing the same thing. Like it's still representing the same symmetrical things when it's outside of the equator as well. That's why what I'm saying that it's based on two hemispheres of vision merged together.
So let's talk.
So when you multiply out those lines, it comes out to be the same thing on both sides. It's symmetrical. You say it's because of a globe. I say it's because of a symmetrical coordinate system.
Okay, so tell me then let's go to the ground. Let's go to the ground and get out of the sky. So if we go to the ground with, I'm bringing up Google Earth here. Sorry, it's just going to take me a second. I don't know why I blocked you. Over here. So if we look at lines of longitude in the south, so let's go. So isn't this the AE map, the azimuthal equidistant, is everything's equidistant from the North Pole, right? So if we were to take this here and go down to, say, Punta Arenas at 53 degrees south, is that not the distance on the flat Earth as well?
Same exact distance. It's referencing the same exact longitude.
Gotcha. Okay, so we're going to save that. So that's 9,000, just so we know, 9,837 miles. Okay, so we just drew that line there. We're going to hit save. All right, so now we got that. Now, if we take, again, what the radius of that circle is, which would be, again, 6.28 times that number, what I said here, which was 9,837. So times 9,837 equals 61,776. Okay, so we can divide that by 360 to get the amount of miles per degree. So when we do that, it comes out to 171. Okay, now let's go down here and actually measure it and see what it is on the Earth, because 171 would be a flat Earth result. So let's go down here and see what we get. So we're now measuring a distance between 1 degree of longitude. Let me see if I can see them. So there's 70 point, let me get it down to where it's easier to see them. So there's 71.3 to 70.3, right? So we're going 71 to 70, and that distance is 40 miles. So the flat Earth predicts 171 miles. The globe Earth predicts 40. And what do you want to bet if we go down there and measure it? What do you think we'll get?
You'll get the symmetrical value for the coordinate system of which it's using. Like you're, again, doing it incorrectly and then concluding that the distance would be different.
So wait, how am I doing it incorrectly?
Projecting the same thing. Because the method of determining the distance from any southern point on the North Pole to using 2 pi to get the miles per degree just makes huge circles. And to determine the distance on a flat Earth, that's what you guys think. That's how you guys.
But this is all I did was I figured out what the circle is. I'm sorry, this is not a circle.
We're using the same coordinate system. It literally can't be different. It's referencing.
It literally can, because one of them reconvene on the globe. The lines of longitude get back together at the South Pole. So what do you mean that wouldn't be different? This one here shows the lines of longitude go to the very outskirts and keep expanding. On the globe Earth, they converge. They're very different. And so, yeah, in the north where we all live, it actually makes the flat Earth make sense. That's why going to the south changed my mind. That's why going to the south should change everybody's mind. If anybody goes down there and watches the damn sunset, you're going to realize, oops, this map cannot be right at all. It's so wrong, it's ridiculous. And one of those examples is we just went to 53 degrees south here, and we calculated the distance of this circle. And then we divided by 360, which is how you'd get the degrees per degree. And it's 4 times off. That means that as a plane left here, if a plane left here and went to fly across this ocean, it's going to have to go 4 times further than the globe says.
Bro, respectfully, that's a misrepresentation of how to use this coordinate system. You don't even draw.
Oh, so this is not a map then.
A curve on that map is the same is the same length in the south as it is in the north, although it visually looks bigger because it's projected out.
That's impossible.
But it's literally, bro, it's math. It's the same exact thing.
Hold on a second. So if 2 people are standing next to each other near the South Pole, they would be next to each other. According to this map, you would have one person here and one person here, and they would be next to each other. Those 2 people are standing next to each other. So is this person standing next to them. This person standing there next to you. They could hold hands. They can hold hands, dude. Wake up.
Yeah. No way. Are they referencing the same coordinate system that's derived from single observer observations?
Hold on a second. If these people standing out here can hold hands,
it's not going to be a different number.
Hold on.
Are there other people out there holding hands?
Dude, If the people out here are holding hands, this is where they would stand, and they're holding hands. So
Are there people out there holding hands?
That's if people stood around the South Pole and held hands, that's what they would do. That's where you would plot them.
So listen.
So I'm confused real quick. Is you saying this is a map or not a map?
I'm saying that when you're talking about a distance being different in the South based off of how it looks in the North, I'm saying if you're using a latitude and longitude coordinate system, there's no difference. It will visually look like a longer difference, but you could take the same exact distance in the North, transpose it in the South. It's just a math function. It looks bigger. It looks like it's a bigger thing because it's projected out and stretched out. That's
man, you're way the North.
It's not physically a different distance when referencing the coordinate system.
But all the lines of longitude converge on the North, so they must do the same in the South then.
Yeah,
but they expand. So the reason they do
you're
in real
looking at
life,
a projection, Jaron.
Right? It's a projection of a globe.
It's a projection of a coordinate system of two hemispheres merged together. We just went over the ground curvature.
And so the way we could tell, but we would,
so if it's actually a globe and there's 4 million miles of no curvature, bro.
Man, it's just, you're not getting it. That these people around the North Pole could stand together and hold hands, and they would actually be touching hands. In the South Pole, the same thing is true, but on this map, it's these people are completely separated from each other. So to bring it back to reality means we have to bend that outside back to a ball. You grab it and wrap it around there, and you'd be back to where the reality is.
Show me your hand-holding party, and I just showed you that there's no curvature for 7 million meters.
Yeah, well, you showed me that there's no change in the height of the sun off the Earth, which I wouldn't expect one. It'd be like you looking at an airplane and saying, hey, that plane that's flying 35,000 feet the whole time is flying flat. No, it's not. It's flying over the globe. It's staying the same distance from the ground.
Then how do the stars and sun set, bro? The whole model's predicated on the physical elevation change. That's why the congruent triangles for the celestial theodolite shouldn't be possible. That's why what he showed with the eclipse stuff, there should be a giant arc for both of them. Let me show you this real quick. We have it simulated out.
Hold on, I just want to, I did say I would read super chats and I didn't get to that. But my point is that we can, so we have to be able to test what somebody tells me the Earth is. Okay. So if somebody tells me that the Earth is flat and I say, okay, what is it laid out like? Are you saying that there is no answer to that, or is it laid out kind of like this? The real Earth that we live on. I'm not asking for sky coordinates or anything. I'm just saying the real Earth that we live on, is it, if we were to get above it and look down, would it look like this?
It probably geographically looks something like that. The
Okay.
coordinate system that we use, though, does not represent that.
Right. But because the coordinate system that we use wraps around to the bottom of a ball, meaning that this location is the same for everybody out here. That's our coordinate system, though, right? No, I'm asking
respectfully, though, think about this.
Okay.
If it wraps under a ball, right? There's going to be a physical elevation changes in the true positions of the bodies. And that's never present. That's what we just substantiated. So however it works, falsification is independent of replacement. And that's the sentiment that you previously agreed with not so long ago.
I do agree with it. So if you are able to refute the globe in a way that has no answer.
Done.
How? I just gave you the answer.
No, your answer conflicts with how stars set. Like think it through. Somehow they all stay the same elevate. Like, bro, regardless of the angle that they're viewing it with, he derived the same elevation. So it should actually be a different angle going down following the celestial sphere. If you can see the screen share that I'm showing.
So what you're saying for one person, let me just ask you. So you're talking about if the globe guy. Hold on. What are you showing?
Okay, I'm showing a simulator of what.
Where are you showing? I'm talking about. What are we looking at? Oh, I see it.
Yeah, I'm screen.
Sorry, I thought you were talking about that. Okay, got you.
Yeah.
So let me.
So look at this. On the top here, we have flat Earth. On the bottom here, we have globe Earth. The celestial bodies changing in elevation following the celestial sphere is how this should work for an eclipse. These two bodies should be changing in physical elevation relative to each observer as we calculate it. There should be a change in this physical elevation. But what actually happened for each person, right, regardless of the angle, came out to be the same elevation every time. That's what he was talking about when he said we're going to have to look for consistency across the data set for the elevations because we don't know what the elevation should be. But can we calculate the same elevation? For all observers, for all 6,200 some data points, This is the end result of this, that they travel parallel to the ground. There is no answer for this on the globe. The whole globe is built on this happening. They tell us this is happening. Before the celestial
Wait, what do you mean,
light,
what's
we had
happening? You
no-
just keep saying words. So what do they say the globe is? Nobody says we live in the middle of the globe.
for the globe.
Okay.
Oh,
I know
the
that that's
globe.
where they take the observations because it's the same thing. But okay. But
listen,
nobody's saying we live there.
listen. The physical elevation change is represented by this. So you're on a globe.
Represented by
This is
what? That little
the
dot?
This is the celestial sphere for the globe.
Okay, but how would I know that?
Right?
How would I know you're not showing me the Earth?
I'm trying to tell you
Okay.
that right now. I'm telling you that right now. It's labeled globe Earth here. Right
Thank
now,
you.
But
Okay.
I know it's really small. But anyway,
So you're talking about
that's what I'm trying to tell
hold
you.
on. So
That's what I'm
that
trying to
blue
tell you.
circle is the celestial dome, or the blue circle is the Earth?
The celestial sphere.
Okay, got you.
Okay.
And then you have
So,
somebody on the top of it,
or-
though. What's that person up at the top doing? What's that line?
The person on the top. This is a separate thing. This
Okay.
is for flat. This is for flat Earth. This is what an observer would see, just on the surface of the
Got
Earth.
you. So he's sitting there flat Earth, and then as the thing moves away from him, it is changing height, right?
Well, the apparent positions, as they're mapped out, they appear to be changing height, but the actual elevation that's derived comes out to be almost no change.
But not from the same location. I mean, because you agree that the sun is moving away from you, right? So how could it stay the same distance from every person? If I'm looking at it and it's moving away from me, hold on. If you're talking about at the top is the flat Earth, so that person, isn't that sun changing distance for that person?
Yes, apparent.
Okay, but you're saying it doesn't really change position; it's the same height all the time.
It doesn't change in elevation. Yeah, correct. We perceive it arc and go down. Like we perceive this,
Right.
and the globe also says that this is physical, but
Okay.
this is actually what was measured and what was plotted out.
I thought you said it measured the same distance at all times. It can't. You're looking at it right there. We can see it change distance.
The same altitude.
But it's changing.
observer
We can see it
calculates the
changing.
same altitude,
We can see it changing.
and it's the same altitude for every observer, bro.
But
That's
we can
why
see it
stays
changing.
parallel to the- Where are you seeing it change?
Okay, so watch when it starts moving here. So that's going to be a certain height away from that person. Now, as it moves, it changes height. That's changing. It has to change height right now. It's moving far away from him. I don't get how you don't understand this. If that you're telling me that light up there is staying the same height from the people on the Earth.
Yes,
Observer. Okay. So
always.
okay, but on this example you're showing of a flat Earth, it doesn't do that. You're moving it away, and it's changing height away from the person on the Earth. Look at it grow. Now it's going to shrink.
Yeah. Did you see the scale of the change? It changes by like 10,000 meters. Like there's almost no deviation here. They consistently produce the same height for every observer over the 6,000 data points, down to 0.01 of a change
At the same time or at different times?
Different times throughout the whole course of the thing.
Right. So it's just basically calculating that for each person on the Earth, the sun and moon are always the same height above them. If you wait until it's above them.
Dude.
You're not explaining this well, though. You're not explaining. If you explain it like I'm a beginner, then. Because what you're saying is not making sense. If you're saying that on a flat Earth, that the sun and moon stay the same distance away from an observer when it moves away from you, is that what you're saying?
No, man.
Okay.
I'm sorry.
Yeah.
It's calculating it for every observer across the whole path length of 7 million meters.
Right.
What every observer would see.
Okay.
And what it comes out to is that it doesn't change in elevation.
Okay, so wouldn't we get the same answer if we looked at an airplane? An airplane flying at 35,000 feet that is flying, and you took its distance away from anybody standing on the Earth at any time, then everybody would get the same height. The plane is flying 62,000 feet or 32,000 feet above them.
You would get different elevations.
How? If you're, that's what I'm asking you. So
because it has different angles.
Because it's
So
okay. So it's moving.
It's a function of the rise and the run to it. So all we're doing here is changing the distance and angle, and it comes out to be the same elevation every time.
Right. So if we did the same thing with an airplane, why would it change? Because the airplane is also going at the same distance above the ground the whole time. So that's why I guess I don't understand what you're trying to point out here. Because if I would expect what you're saying is happening, I expect that. That's all. I don't expect the sun to change its height per person.
You're expecting the wrong outcome because the whole model is built upon the physical elevation change of it. That's why there should be no relationship between like the occlusions when we're doing the mountain peaks and stuff. There should be no relationship with the peak at that elevation for the occlusion for the observer. It has to change. That's the whole purpose of it. That's what creates the curvature for it to exist as. Like that's what the whole model is built upon. The drop over distance, if you double that comes out to be how much the physical elevation change occurs in the star. Like that's literally the whole model. That's what we're testing here. That's the purpose of this. Let me show you this diagram real quick to try and make it apparent here. And then
I mean, anything that can be explained should be able to be explained easily if you have a grasp of it. So I would think if you have a grasp of this, you'd be able to treat it like I'm a second grader, fourth grader, and you explain it to me. So far, you're just saying a lot of words and then bringing up different graphs. That's not really teaching me anything. It's not showing me what is actually happening. Like if you were really trying to show me, you'd show me here on the Earth, if this person stands here, he measures this distance, and this person stands here, he measures this distance. You're saying it always is the same distance, but then you're showing on your graph the distance change. That's what I'm saying. As that line moves away from you, that distance changes from the person.
Is the elevation of this changing as the distance changes? Because that's what's supposed to change.
The elevation from the circle down below?
No, from right here, from anywhere. Because this is, okay.
You're talking about the elevation angle or distance? What are you talking about?
Okay, you see this, the sun
and moon. I see it there.
Right here.
Yes.
Okay. These are supposed to physically change in elevation and arc down like this. This is what's supposed to happen on a globe.
Because they have to stay the same distance.
When you plot this out for every observer, you're going to get you would get a physical elevation change over the distance. That's what would create ground curvature. That's the graphs that he was showing where it didn't do that and all that. This is a 2-scale simulator showing all the data points plotted out and what it would look like if it's following the curvature of Earth versus what was just plotted out with no elevation change. The distance is changing as this moves, but the elevation remains the same. Each observers absolutely cannot derive the same elevation on a globe. It would have to follow this. The whole model is based on this.
I mean, maybe I'm the one that's not getting it. I don't know if people in the chat get it, but let me look at the super chats real quick and we can come back to this because I am not grasping what we're looking at here. Still, I don't know why the line's coming from the middle. I do understand that you're saying from a globe, this is what you would expect to see, but that line is staying the same distance from the person at the middle, right?
No. You see how it's physically changing in elevation though?
But it's staying the same distance from the person in the middle, correct?
Yeah.
Okay. So I'm just saying that that's staying the same distance from the person in the middle, and it's on a curved path, and it's going down away from that person. Now you're putting them up on.
And it's showing the physical elevation change. This is what would happen if there was curvature for this to change on. But this is what was measured. This is what was plotted out and measured.
But we know that the sun's going to end up on the other side of the Earth 12 hours later. Well, in that model that you just drew, it's just going to keep going out forever, right?
Bro.
Well, just saying that it seems like to me what you're doing is you're conflating both models. You're saying you're putting one model and then saying, oh, this would work on a globe, and that is what we see. And then you say, oh, but it's not what we measure. We measure this angle not changing, right? In which case you're saying on a flat Earth that the sun and moon are just moving like that away from you, right? Like this line that you drew up here.
Yes, the objects that we see, how they arc and get lower in the horizon.
Okay, so wait, but the distance then to the ground is changing.
That's just how we perceive them.
Okay, but the distance to the ground is changing, and we can figure out what the amount that it would change in angular size. If you're telling me we now know the distance to the sun and moon on a flat Earth, then I can calculate what the change in their angular size is.
You're conflating models.
Okay, let's not conflate models. Let's just go to just flat Earth. Let's go back to when I'm a flat earther. I'm a flat earther now. I believe in the flat Earth. Okay, You're now telling me that we can calculate the sun and the moon distance from the Earth. That's what you're saying. From the flat Earth.
I'm telling you that's what the trig comes out to based on the occlusions.
Okay.
It's rise over run.
So we are accepting the trig, but if we look at the angular size change that is expected, we're not going to see it.
If you're assuming the sun is a physical body that you're seeing.
Well, that's what you were assuming. You're assuming that.
How so?
Because you just told me that the distance doesn't change and the altitude doesn't change. So how are we getting altitude and distances to things that aren't physical items?
Bro, it's a calculated value based off of occlusions.
Right. And
Like,
so
we're
if
not
you
saying that-
calculate the
we're saying
value
that
and it
we're not-
comes out
We're not
that,
saying the occlusion doesn't happen.
so really this is what we have to do. We have to
There-
believe that the sun and moon are magical. That's what we have to believe.
No,
Well,
no,
they're not. Are
really.
they physical or are they magical? Or are they apparent? Or are they
Listen.
pretend?
They're apparent in both models, and the elevation change is apparent too. That's what I'm trying to tell you.
Okay. Because yeah,
Whatever
because the sun-
whatever source of light these are, whatever source of light that is,
yes.
we don't see the true thing. We only see what is in our hemisphere of vision. That's what this whole thing is plotted out against. This is what
Right.
this is how the whole thing works. And when they say, okay, we have the true position, which is just the zenith measurement of where it was, and then
Yeah.
they add 15 degrees per hour to it. They're like, okay, it's following ball curve. As it's getting lower in the horizon, that means it's physically getting lower. They even attribute negative coordinates to it and say now it's below the ball. This can't be below a ball if it's also in reality physically still above us.
Okay, then it would never set.
I mean, if you impose conditions on it where light propagates infinitely,
Well, I mean that's okay. Well, so you're saying yeah, you want to go with light attenuation and it's not infinite light. Okay. I'll give you that. I even think that might be the case anyway. So, but I don't understand how I'm supposed to just give up on the ideas of things changing angular size. If we know their distance, right? Like I never could say that as a flat earther. I couldn't say I knew the distance of the sun because it didn't work out from 3 observers. It only worked out from 1 observer or 2. I mean,
right, dude. And that's exactly how the whole model was based, bro. It's a 2-party celestial navigation system. Like that's what the part of there was like a royal decree in 1777 where they were giving a financial reward for people that could make the coordinate system work in the way that you just described it for 2 people.
Okay.
The whole idea of like drawing triangles to the sun for 93 million miles and all this stuff, all that is supplemental. If you want to actually like use the globe so-called and like do celestial navigation, all of it changes all the distances are assumed to be the same. They just make an equidistant web.
Right.
And what we're showing here is that there's no elevation change in the way that they say that there should be.
So let's say that this was happening and the stars were out, right? So the stars are moving with it. So you're saying that everything then moves parallel to the ground? The stars don't move either? Because they follow the same paths.
No, they follow the same path, but it's apparent. The actual elevation isn't changing lower. That's why they get occluded by mountains at elevations that don't change.
Right. And so do the sun and moon, right?
Apparently, yeah.
They get occluded by mountains. I mean, that's what the sunset would be. Correct?
Oh, yeah. Sorry. I thought you were talking about the eclipse data. Yeah. Yes.
Okay. So I'm just trying to say, so then you're saying that all the stars never actually go lower. They just are staying the same height above the person on a flat earth at all times. As they move away, the altitude stays the same.
Correct. The
Okay.
actual source of the light is physically staying the same altitude, even though it's being plotted on a coordinate system that says that it should be changing in elevation physically.
So then that means that the light of stars is much greater than the sun. Because they're also staying the same height away from me, and that I can see the starlight way after the sun is gone. So that means that the sun is not as powerful as the stars in the flat earth model.
Bro?
Okay,
Bro.
listen, if you're saying, hold on a second, just imagine that we're looking at the sky and the sun and moon are moving in the sky. The stars move the same speed about. I know it's a degree off or something, right? But they all move the same general speed. Correct?
Yeah.
Okay. So you're saying that the sun and moon don't change their... Oh, that's when we came in. The sun and moon don't change their altitude away from the person on the flat earth. So then neither do the stars.
And neither do the stars.
Okay. But if we watch the sun goes away and it sets.
The apparent sun sets, absolutely.
Okay, and then if I'm still looking in the sky, I would still see stars past it. Right? The sun sets, I can see those stars.
Yeah.
Okay. Just making sure. I'm just making sure that that's what you're saying, is that those stars must have a more powerful light than the sun, because the sun goes away, goes out. It diminishes. But the starlight, we can see much further than that. Are the stars further than the sun? Let me put that. Maybe that's the problem.
No, bro, I have no idea how far they actually are in elevation. But what I'm telling you is that the source that we see, what we're basing this off of, comes out, what the globe is, saying is true. We're representing it over a flat earth, and we're showing that the apparent angle changes are just apparent. They're not physically changing. That's a huge problem, because irrespective of the distance of the stars or the sun, they should change in elevation physically as per what the model dictates.
And is that the right height? The way is that scaled correctly?
Yes, this is to scale.
Okay, so go to the flat Earth part at the top, and then put like a where an airplane would be above that person.
Oh, I can't edit this.
No, not edit it. I mean, just put your mouse there so I can see.
Okay.
So I don't know what the distance is. What is that distance between the ground flat earther and the sun and moon up there?
3 times 10 to the 6.
What? I don't know that math.
I don't know, like 3 million meters. It's just
I don't know meters either. Okay.
So let's just say 10,000 miles, and then so now I got the guy at 10,000 miles.
Okay. The plane's that close to the sun?
Bro, what?
I'm asking you to put your fucking mouse cursor where a plane would be above the person on the flat Earth. It's not difficult what I'm saying. Put your mouse where the plane would be.
You just anywhere would be.
No, where a plane flies about 30,000 feet. But I don't know your scale, so I can't tell you where to put it. You have to tell me.
I got you. My bad. You said to scale. My bad. I thought it was just like anywhere.
No, I want you to put it where the plane would be.
I got you.
Because if we, so go to 30,000 feet, whatever.
30,000 feet to meters. 9,000. Okay. Here's the. Oh, my bad. Okay. So about 9,000 here. All right, here we go.
Okay, now zoom out so we can see kind of in reference to where that thing is. So that's 30,000 feet where your mouse is?
Yeah, thereabouts. Yep.
Okay, and then you're saying that so when we see out the window of a plane and the sun and moon are lower than the airplane, how does that work in this model?
That's just apparent, bro.
Okay, so I'm asking you how it works in this model. You're saying that perspective moves things lower than our eye position?
Yes. Sometimes people will see the sun in the clouds. It's just an optical illusion.
No, well, the sun is in the clouds because it's above your head. Nobody sees it.
No, I'm sorry. No, like, have you ever seen the video where they're like on the plane and they like show like almost what looks like the orb of the sun? Like that's in the
okay, that's not what I'm talking about. I'm talking about you can actually see the
like,
sun.
like, look, it's close. That's all just optical illusion stuff.
But the sun and moon, we see them go below the plane, the airplane, below the plane. You can actually see.
It looks like it is apparently, but it's not.
Okay, but how about with like airplanes? We can see the bottom of airplanes lit up by the sun, which you can't see.
You?
Absolutely.
Okay.
Do you want me to show you? I mean, well, that tells you that the sun is lower than the airplane. The sun is lighting the bottom of the plane.
Show me your examples of plane lighting under the thing. But what I'm showing you right now is that there's no physical elevation change.
Right. And so but the reason I brought this up is because then that would require the not to be possible to what I'm saying happens.
Dude.
Right?
Light being reflected onto an airplane or whatever is going on with that. Like, you have to show me.
Okay.
I'm not familiar with. But show me what you're talking about. And then, but what I'm showing you is that they're never changing in altitude. Now, if you do this same thing on a globe where you're traversing over a globe, right? With our,
I'm just trying to point out that there's evidence that the sun drops lower than your eye view many times, lower than airplanes. And if you're on a mountain, it drops lower than your eye view. It drops lower if you're on the beach, but that's hard to see because you're right at the water level. But
and that's always apparent.
Okay, so what I'm saying is if it's apparent...
You're never physically higher than the sun.
Right. You are. I mean, that's what I'm saying. So if you're not physically higher than the sun, then how would sunlight hit the bottom of an airplane? Would it do that?
You have to show me what you're talking about.
Get in there. 1 second. I don't know how far back it is in this. Let me find it if we can. Where is this? Nope. I'll find it here in a second. Maybe somebody's. Oh, there we go. Thank you. Share. And I know that Dave McKeegan did a whole video on it too. I was going to find this video though. Can you put this one in here? Telegram. Let me save this. Or Dave's one. Because I think if we can show then that there's evidence that obviously the sun does go down. All right, let me find it here. Oh, I know what I would look up. Let me look at this. This is it right here. Let me bring up this.
Hello.
Bring up his video of this. So yeah, this is right here. Let me see if this is it.
As if you zoom into the underside of a plane when the sun is already set, why is the bottom of the plane lit up? You can clearly see the bottom of that plane is not lit up. Only the top is lit up. I can do this with my P950 and get even better shot, but I don't have it out here right now, so I figured I'd do it with my cell phone. The sun is has set behind the horizon over there, and you cannot see light on the bottom of the plane. The bottom of the plane is shadow because the sun is still above the plane. Just like it's still above our plane, it's just moved far enough away to where we can't see it anymore. So Dave McKeegan's simple observation to debunk the flat earth is just ignorant.
Unfortunately for Joe, though, he's actually just perfectly demonstrated my claim.
Oh.
Now, to be clear, I never claimed that the sun is always visible on the underside of planes. It depends on multiple factors, like whether there are clouds blocking line of sight of the light from the sun to the plane, how far beyond the horizon the sun is, and how high the plane is. If it's too early before sunrise or too long after sunset, then the sun might have already seen to be.
Can you just listen to this part on YouTube? I don't know how it's not picking up my sound.
Can you send me the link and I'll play it real quick.
Wait, the link to my show or the link to this video?
Video.
Yes. I'll put it into Telegram. If I can find you. Oh, there you are. Okay, here you go. That's that video. Yeah, just listen to. I'm actually. What time is this at? He's at. It's only 8:14 video, but just listen from 5. Well, it's almost 6 minutes. You can listen from 6 minutes on 6 to 8, so it's only 2 minutes you're gonna be listening to. And I'll play it for people here, just so you can hear the explanation there.
Be set for the people on the plane. If the plane is at lower altitudes, like the one in Joe's footage, then the sun will set sooner for them than it.
I didn't send what? Sorry.
You didn't send the link yet.
I didn't hit enter. There you go. Sorry.
If the plane were at 30,000 feet, and you only get the reflection when the plane is in line of sight between you and the sun. So if the plane is flying towards or away from you towards the direction of the sun, then this reflection can last a couple of minutes, whereas if the plane is flying perpendicular to you and the sun, then it's going to cut across that path pretty quickly. But the sun would never reflect off the underside of a plane on flat Earth, as Joe himself points out, because the sun would always be higher than the plane.
The bottom of the plane is shadow because the sun is still above the plane.
So not seeing a reflection on the underside of one particular plane does not disprove my observation for the globe, but seeing the sun reflecting off the underside of any plane disproves the Earth being flat and the sun being higher than the plane. And eagle-eyed viewers may have noticed that as Joe zooms in his video, the underside of the plane lights up with a reflection of the sun. Someone actually commented about this on his video, but he tried to argue that that's not the case and that the light is reflecting off the top of the plane. Except here is a frame grab from Joe's video as the plane is lit up. And zooming in, that is clearly the underside of the plane. We can clearly make out the shape of the plane. I mean, the tail of the plane is a clear reference marker for where the top of it is, and yet the sunlight is on the opposite side, meaning the sunlight is reflecting off the underside of the plane. It seems quite ironic that Joe claims that attempts to debunk flat Earth always fail true scrutiny, and yet his attempt to debunk the globe has not only just failed scrutiny, but he's also just debunked flat Earth, because by his own admission, the bottom of the plane must always be in shadow because the sun is higher than the plane. And that's going to be it for this video. As always, feel free to leave.
He does another video where he does some actual examples, but I'll show you one that somebody has that actually shows a better light underneath the plane. because again, what he's saying is that Joe went and filmed one plane and said, look, there's no light underneath it, even though in his own film there was. But like Dave said, not seeing it one time is not evidence of anything. You'd have to, but yet seeing the light shine off the bottom of the plane is evidence that the sun must be lower. Because there's no example. Now you might go to clouds, but the difference between clouds is light shines through clouds and it doesn't shine through planes. So we would never have a case where light should be seen underneath a plane unless the sun is physically lower. But again,
we'd have to get some more information about the flight to determine like angle of the plane. Like was it turned a little bit? Others.
No,
like,
but regardless, how could it have the sun underneath it?
What was it flying over? Was it flying over the ocean or something? Like there's other factors to consider there. I wouldn't argue that seeing this reflection on the underside of a plane proves anything. It's apparent. Like,
it's not apparent.
The sun,
how could it? You can't show anything that has light hitting the bottom of something that the physical light is above it.
Bro, you showed a video of a guy filming a thing. We don't even know what the plane was flying over, where it was, or what the if it was or we don't know the pitch or the yaw of it. Like there's a lot of other factors to consider to explain how a reflection happened on the bottom of a plane versus no altitude change over 7 million meters, dude.
I don't know about 7 million meters, but that's, again, I don't even know what that distance is.
It was the length of the shadow going across America.
Right. I guess what I'm confused about that is, again, don't you expect that? Let's say the Earth were a globe, and you had people in California and New York. Would you not expect the sun and moon to be the same height for both people?
No. Look at this right here where I'm zoomed in on.
Where are we looking? Hold on. Sorry. Now you have to tell me where we're looking.
Oh, sorry. I have to reshare. Give me 1 second. I think I have to reshare. StreamYard. Share. Screen.
I've never seen this video. I don't know about this one.
So look, check this out. You see how on the globe, as you get further out,
hold on, let me bring it.
It starts to get lower. There's a deviation in altitude.
Hold on, nobody can see what you're doing yet. Hold on. Okay, go ahead. We can see it.
Okay.
Now.
So as we start off on the globe, as we get further away, the curvature starts to become more apparent. You see how I'm scrolling out, and this is starting to get thicker.
Yep. Okay.
So if we extended this out for 7 million meters, what we have here is a deviation from a plane elevation. So something has to, if something's following the curvature of Earth, as it's setting, then there's going to be an elevation change for the observers that are viewing it. You can't calculate the same elevation over the 7 million meter distance for everyone unless the object is actually also still parallel to the ground with no deviation. So when you say like you expect that, you expect the wrong outcome.
Okay. And you've seen before like sunset on where the mountain gets the light last and things like that?
Yeah, tons of that. There's actually a good video of it right now I can bring up. It's just another instance of for example, if you're standing in the shadow, that's the way you'll see it. When you stand on top of the mountain, you see the same shadow going out to the horizon. It's just an optical illusion based on where you're standing. The shadow alone, based on where the observer is at, doesn't tell us anything really unique, except for it's been a minute since I looked into the shadow thing, but there's a whole bunch of stuff on.
Let me do the super chats because I told people that and I'm lying now, so I don't want to lie. Okay, let me go to the super chats. I'll read you those real quick. Super chats. All right, so we got Dave's Waffle House. Thank you very much. £2 says top man, big respect. JSS Tiger $5 says, Alan, you don't do math. You don't have the right to present yourself as an expert on celestial mechanics. Okay. From Jesse, $5 says, Alan lied about the formulas, claimed to have a formula that worked, but would not give it to me. What he had previously given me didn't match reality. Any response to that?
Yeah, the formula that we gave has always been the same formula. They're published right here on the notation guide for the celestial theodolite. There's never been a different formula. Like, ask them for the different formulas. Like, I have no idea what.
So anybody can go to that page and they can get the formula and they can do that themselves.
Yeah, it's all based off of rise over run, and then there's a little bit of central angle theorem that we reference, but it's all straightforward. It's the most basic trig you could do.
Thank you. We've got Kango 4457. Thank you for the New Zealand dollar. Says, Alan, everything we see is apparent. It is a refracted pencil in a glass of water has real position. So the sun has a real position. Just say magic. It would be less embarrassing for you. The sun sets because of magic. Okay, we've got from Jesse, $5 says, if Alan won't debate me, just have me on and I'll show that he's deceiving people with the celestial theodolite BS. His results do not match reality. Okay. From Jesse again says, the flat earth model predicts whatever magic is needed to make the flat earth appear to measure like a globe, including sunlight bending 100 degrees. Well, more than that, 180 degrees, really. From Jesse says, Alan lied about my CT measurement at 25 miles being indistinguishable for flat versus globe. He's previously agreed that 25 miles was sufficient distance. Okay. We've got Slitherly.
Real quick, let's pause. Let's pause on that real quick.
Okay.
It's not about the distance. It's a ratio of a triangle. It's a combination of distance and elevation angle. So the mountain that he specifically went to and chose and made a simulator to see if it would work was like the lowest possible angle that you could get. And it's not about just the distance there.
So it's a very small window that it works, or it does work universally.
No, dude, the globe only exists as that ratio for the measurement. Like what he did specifically was went to where it would work out. Everywhere else that you go, where you're not trying to specifically fix the ratio to get it, it's not close to a globe.
Okay, so like if this were real, I just want to say something. If this were real, then there would be a way that people could go and verify this themselves. So there's an easy process to do this. No,
bro, that's actually, you just reminded me of something.
Yes.
Not only is it repeatable and everyone else can do it.
Okay.
We're actually paying people to do it.
Okay.
Now
I've seen people request that, but I didn't see anybody answer it.
Yeah, we have the see, I just put out the celestial bounty. So am I still screen sharing?
Yep.
So right here, if you could put this in the chat or put it in your Telegram.
It's on the screen, but go ahead.
Forward it to people so that they know where to get it.
Okay.
We're offering up to we have a $300 pool, $50 per measurement. All you need to do is have the ability to record stars at night and make sure that the peak that you're filming is distinguishable. So in the example here that we're looking at, you can see the star, you can see the outline of the peak. That's all you need to do. The quality can be a little less, but as long as it looks like that, you're good to go. All you need to do is write down your latitude and longitude coordinates of where you're recording from, the name of the peak, which you can get from a Peak Finder website or something similar. You could look it up so we can get the necessary information from that.
Okay.
And you just need to give us the timestamp for when you started the recording of your video so we could math out what it would be in real time for the star's position and stuff. So we just need most recording devices will start the file name with the timestamp of when you recorded it. So if your device does that, you're already good to go.
Okay.
That's all you need. Just record looking at a mountain and have the mountain in the center, obviously for the peak to make it easier and remove ambiguities, and that's it. And so in the south specifically, as well, we have a bounty going. So if we need some southern hemisphere observation. So if you live in the south, any distance, there's no like bad distance. It would be interesting to see what happens over a wide range of them. But what we found is that if you're about 5 miles away from a peak, there's not really any distinguishable distance. So preferably, if you could be 10 miles plus and do increments of 10 miles out, you could even use the same peak in the same night. So you could make $50 per video per star occlusion, so long as you're following the distance intervals.
Okay. Thank you for that.
That's it. And then in the north, if you live in the north, if you live at sea level, we need some more sea level measurements. We were only able to get 2 of those, and so we need to get some more.
Okay,
so
we'll keep going with super chats. We've got where are we at here? Alan, we read that one. Okay, so we got Slively says, "What's up, Jaron? How do you feel about our $50 vast bet for 2026 now that their tech demonstrator is now in orbit?" What? I don't know. I don't even remember making that bet, but it sounds like me. So I'll have to look into it. You said vast. So I said that VAST wouldn't launch. Is that what it was? Or VAST wouldn't go to space?
Oh, dude, I was going to ask you about that too. So do you remember that guy you bet for the Artemis project, I think it was, or something?
No, it was for Dear Moon.
Oh, yeah. Did that guy ever pay you out or
nope.
What happened with that?
No, you said he wasn't. No? Now, the nice thing was that because MC Toon, he thought he was going to convince the guy to pay me. So MC Toon paid me the money and then said he'd get it from the other guy. And he has not paid MC Toon. So,
oh wow,
yeah, he's just a dirtball.
Shout out to Toon for
shout out to Toon. Shout out to Toon for that. That was nice of him to cover that because I would have just kept going after that guy and calling him a dirtbag because he just basically said, "What's he going to do? I'm in a different country." Like, oh wow.
So
nice
Jaron, real quick, in between super chats, let me show you this simulator. That
hold on, let me make sure you're on the screen.
so
you
that
are?
he could cherry pick an observation to fit the ratio needed where it's indistinguishable. So what he did here is if you just move this slider here, right, when they become indistinguishable, this is where he went to go make his measurement. That doesn't that's by definition cherry picking.
Okay.
Like all the measurements that we have are the ones that came from Mike originally. He lives in Colorado.
Right, I know
There's
the original
mountains to
ones.
his east and to his right, or there's mountains to his east and to his west. He just picks the ones that he could see. Kat and I got a C-star, did measurements. We did one in the parking lot of a Dollar General that was shut down. That was our closest measurement at 5 miles, and then we did another one that was like 49 miles. So there's a lot, like building a simulator, looking for a spot where there's no difference, going and measuring it, and then concluding that it doesn't work.
I agree with you. That's not the way to do it. Okay.
Even though even though the emergence happened with our principles and all that, he's like, it's
so
just
you're claiming that if we
rhetorical.
moved anywhere else, that the globe result would be worse off than the flat result.
It's like that everywhere.
Yeah, so I'm just getting you to verify that.
Yes.
Okay.
That is what the data shows.
Okay. We've got. Have you gone full redart? No, I don't know what you're talking about. I'm not going to argue things other than what I know to be the case, which is the shape of the Earth. So besides that, if you're talking about NASA missions and stuff, you're not going to catch me debating that. Human being, thank you very much for joining the club. Jesse says Kevin Samuel thinks Alan is good at math, but Alan can't recognize that the circumference of the equator cannot be 24,901 miles on a flat Earth. 2 pi r. Okay. Does Alan deny Haversine on Earth? Haversine allows for 4 equidistant positions on Earth, but it is impossible to have 4 equidistant points on a plane.
What equipositions are built that function as that? Like, that's not even, like, calculatively that's true, but what even functions off of that? There's literally like nothing.
But on a globe, could you not have 4 equidistant points?
Yeah, no, for sure. Okay. And then also regarding but I'm saying, like, what terrestrial features and what part of engineering is predicated on doing that? There's nothing.
The Haversine, though, isn't it?
No, that's not what the Haversine does. The Haversine calculates distances between a spherical coordinate system. It uses
I know that, but doesn't it use the 4 equidistant positions to come up with that formula?
Not that I'm aware of.
Okay.
All you enter is your latitude and longitude, and it does like the cosine between it. So I'm not sure
about that either. I thought that's what it used, but I don't know. All right.
Yeah.
We've got Alan. Are lines of solar noon and lines of longitude straight? How can they converge going southward and northward of equator if they are straight? Wait, hold on. Are lines of solar noon, okay, gotcha, and lines of longitude straight? Well, yes. How can they converge going southward and northward of the equator if they are straight? Oh, I see what you're saying. I don't know. You don't have an answer for that. Do you? I mean, no.
Is he talking about how the lines of longitude are flat on a Gleason's versus curved on a globe projection?
No, but he's saying lines of solar noon. So if we drew a line of solar noon from everywhere that's seeing the sun, so say it's the equinox, and we draw a line of solar noon, then they converge going southward and northward of the equator, but they're straight. On a flat Earth, they're just straight lines, but on a globe Earth, they would have to come back around and meet, right? South Pole or wherever. We got, what is this person? OMF Glows? I don't know what that is. OMFGOLZ. I think Alan's model is consistent, but he needs to bite the bullet that people at the South Pole could hold hands and be mapped on opposite sides. Well, yeah, I think he gets that's... So what he said is, show me the people holding hands. Now, again, I don't know. That wouldn't convince him anyway.
I basically showed a series of people holding hands, showing that there's no curvature, and then, like, your proposition was they could hold hands if they were there or whatever. So, like, that's why I said, well, show me what you're talking about, because I can show you what I'm talking about.
What I mean is that people who went to the South Pole, they start from 3 different locations, right? Like, you can get to the South.
I got you.
Okay, just making sure, because there's no such place on that flat map that works. Like here, you can't have. We have a South Pole somewhere on the Earth. And let's just say that it's what we used to call it as a flat earther. It's a ceremonial South Pole, right? So they've got some place that they mark in the ice, and they call it the South Pole, somewhere on this map. Now, this person can get there in 5 hours, this person can get there in 6 hours and this person can get there in 7 hours, but they're the same place. So you now need to find a place on this map that we can draw a location, let's say here, and say, now, can those people get there? Can this person get there in 5 hours? Maybe. Can this person get there in 6? Never. Can this person get there in 7? Never. So you're going to have a problem with, we know that the South Pole exists. I know that it exists because I've seen the South Celestial Pole. So what else would be below it? I mean, you'd have to now invent something that doesn't make any sense. I saw it. We were here. Wait, where were we? Here. And it was about like in this area, the South Celestial Pole. And when we flew to Union Glacier, it'd be out here somewhere. Okay. So this is the South Celestial Pole. Below it is the South Pole. Now I knew that by going in that direction, whenever the sun was at its lowest, so say the sun's coming around here, and it's at its lowest at 15 degrees. If I walk towards that, the sun's going to rise up by 1 degree every 69 miles. So the same thing is true no matter where these people are here. We're all at the same longitude. So we're all at 80 degrees south right here, right? So, or let's say we're here at 53 looking at the South Celestial Pole. That means somebody here at 53, somebody here at 53, somebody here at 53 are all going to be looking up into the sky, and they're going to see the South Celestial Pole, and they're going to know the South Pole's below them. So they could all walk in that direction. Yet on this map, it's all opposite of each other. We'd be going this way. And yet we would meet in a very short time at the South Pole. That's how they found the South Pole. So this tells you that this map can't be right because this has people going in opposite directions. Where on the globe Earth, they meet at a point, and that's what happens in reality. And anybody could say, oh, Jaron, you don't know that for sure. Okay, what that would take is that you would have to have a world where somehow they knew that at Union Glacier, it matches perfectly the globe model, meaning that when we flew out here, they knew, well, let's say we're at Union Glacier, they knew that right there, they're like, yes, they would only be 600 miles from the pole, but it's really, much, much more from somebody over here at the same longitude or the same latitude. And somebody over here at the same, no, it's the same for everybody. If everybody is at where we were, 80 degrees, they would all see the sun do the exact same thing, 15 degrees in the low, 35 in the high, if it was the same date. They would all see that. And if we all walk towards the southern part of the sun, it would be in the same direction. Yet on this map, it's the opposite direction. The lowest part of the sun is going to be here for this person, here for this person, here for this person. So they'd all be walking there. This guy would walk here, and this guy would walk here. And yet they would all meet. So, I mean, it just tells you that the Earth cannot be this map. It has to be the globe because that's the only way that reality works. And again, just to show one other thing with this map while it's out, if this is the map of the Earth or this is what we think it looks like, then the sun is required to go to the right like this, around clockwise. Okay, but here in Punta Arenas, when we looked west, the sun went this way. Completely the opposite direction that it's supposed to go. It's supposed to go this way, it went that way, and then it rose this way. Like what? How the hell did the sun do this? Well, it does that because it's actually lighting this area on the other side of the Earth, on the other side of the globe. That's there's a model that gives me an answer that goes, oh, that explains everything I've seen. Same thing with the sunset and sunrise going the opposite directions. Everybody in the north, every time we've ever seen, imagine this is the horizon, and we're looking west over water. Actually, be better if I just get rid of this whole picture. You can make a better sense of it. Okay, so let's say that we are. Oops, let me get this. Looking out over the water.
Bro.
Yeah, you can explain this to me.
An AE map preserves directions. It's an azimuth preserving map. So it's not going to be a different direction, bro. You've got a huge fundamental misunderstanding of conflating the globe and the AE map as a model.
Okay, so hold on. Tell me that. So I'll go back to, let me just tell me this. You're saying that if this circle, let me go right this, let me grab a circle. If we take, let's just say this is the sun path. Get rid of that. Okay, so this is the sun path. So you're telling me that the sun always goes in this direction, correct? Meaning to the right.
I'm telling you how you perceive it is latitude dependent. So if you're in the north,
stop saying that. I hope you understand how dumb that sounds. Everything is latitude dependent. Everything, everything in the sky. So stop saying something that is true every time. Stop saying it.
And what else did I say in addition to that?
I don't know, but stop saying latitude dependent. It's dumb.
Single observer latitude dependent.
No shit. That's how it works in reality. Stop saying that, though. It's the dumbest thing I've ever heard anybody say. Latitude dependent. Of course it is. It changes no matter where you go on the Earth. It's going to change the sky. So it's latitude dependent. So stop saying it.
It's going to do that anywhere. That's how we perceive it.
Didn't I just say that?
If you're in the south, you're going to see it Antarctic. If you're in the north, you see it Arc. It's individual to you.
Okay, but hold on. So this is not the map then. I thought you said that this is the map looking down on it. You have two different worldviews,
no,
dude. In one, you want
no.
us to believe in the real Earth that we're looking down on, then you want to pretend that there's a pretend Earth.
Can you stop interrupting me, please?
No, because I was talking and you interrupted me. I asked you if the sun is moving in this direction, right? Isn't that true? If we're looking down at the Earth, is it not moving that direction? Or you're saying for some people down there, it moves the other direction?
Who's on top of the Earth looking down?
Me
The
right
only
now.
observer-
Me right now. We're looking at
observer
it.
latitude dependent.
Me-
From a God's eye view, no. All
So-
you see is latitude dependent where you're at
Okay.
as the observer.
So
And
just
if
so
you're-
everybody who's
if you're
watching,
north of the equator, you're going to see it go. You're going to see it arc. If you're in the south, you're going to see it anti.
right? So you're saying that the sun goes in
Individual
two
to
different
you.
directions, and we never see it actually change direction because it has to
Seeing
go.
this- I'm-
Hold on.
seeing
You're
the
saying if
sun
there's a
move-
guy here in the south and a guy here in the north, there's two people here. You're saying this person sees the sun go this way and this person sees the sun go this way, yet nobody can explain why that would ever be the case. Except for if you put it on a globe, then it all makes sense.
Well, you keep saying there's no explanation for it. But
Okay,
if you
I'm
see
waiting
it
for the explanation.
if you see it individual to you and it's just apparent, that's exactly what the self-theo is showing.
No, so what you've done now is you've taken the real observation from the globe. You've taken an observation of one thing going left and one thing going right, and you've said, well, that's what you see. It must be dependent on the person because we have to believe in a flat earth, even though the globe answers it without any bullshit. It answers it.
So listen,
Okay, try
when
to
you
answer
say,
it again.
when you say no bullshit, right? You're just talking apparent positions of the bodies. Any model can be constructed of that, as per Copernicus's advice to us. What I'm saying,
Okay,
is
right.
that when
Okay,
you
so we can
have-
draw any
when-
map that we
stop,
want and make it
stop.
work.
I'm literally in the
Okay, go
middle
ahead.
of saying something. When you're just saying, "Oh, this body's here. This is where an observer saw it. We add 15 degrees per hour to it. It'll come back." That's what the whole model is based off of. What I'm showing you is that there's no actual physical elevation change over the greatest distance possible that could be measured.
Okay, that is so
So
inconsequential.
so hold on one second. So when you say, "Oh, it has this person sees their own sun and that person sees their own sun," that's the only way that I could physically explain why there's no elevation change. If there was an elevation change, I'd be a glober. It would be the single-handedly most conclusive proof you could provide. It would be that physically significant. There isn't any. It doesn't do that, bro.
Okay, yeah, and I'll figure out what you're talking about there. I mean, again, I'm a little bit confused on that one. I'll admit that. But on this one here, where I'm just talking about, this is the kind of evidence that should be end of story. Because again, if we look, well, let me just draw this real quick, and we'll come back to this. But if we take this, I was going to draw it before, and I'm just going to say we're looking. I want people to understand that the flat Earth is trying to change this proof by saying, "Oh, well, it depends on which way you're looking." No, it doesn't. Because I'm not telling you to look in any direction but except for towards the sunset. So say this is water. I know it's purple, whatever, blue. There we go. And we're looking over and we're about to watch the sunset. So which way are we looking? Everybody should know. Oh, you're looking west. Obviously, we're looking at the sunset. So we're looking west. Everybody in the north sees the sun set like this, left to right. That's how every sunset is every day. Doesn't matter the season. Doesn't matter anything. It just matters that you're in the north. The sun sets left to right. Now you may see it set a little bit more like this. Or if you're way up high north, you might see it set a little bit more like this, okay? But it sets left to right. Now, when it rises, now which way are we looking? Well, we're looking east if the sun is rising. And every time it rises in the north, it rises left to right. Everybody's in the north. We've never noticed this. We don't pay attention. That's the way the sun always will rise up past the horizon. It comes this way, okay? Now, if you go to the south, now on a flat earth, there's no difference in between the north and the south. Why would it change? But if you go south, as soon as you go south, now the sun sets right to left. And every single where in the south, and it just changes, maybe it's this way, towards the equator, it's going to be more like this. And if you are watching it rise, oops, too far. Watching it rises right to left. Okay, so now this becomes a paradox for flat earth. What you've just said is that two people on the flat earth, let's say this is the equator here, and you've got one person in the south and one person in the north. Those two people are watching the same sun go in the same direction, yet this person sees it go left to right when it sets, and this person sees it set right to left. So now what you have to believe is that Alan just says that, yeah, this person just happens to see it go to the left because it's latitude dependent. Yeah, we know that. But if we're asking which model explains this,
observer dependent as well,
okay,
where they're located.
Of course it is.
So that's the significant factor in this, bro. We're seeing an apparent object always. It's an apparent change in elevation. It actually never changes elevation. So how it works mechanistically, like, obviously.
But this person would actually see the sun, would see the sunlight on the water here, and this person's going to see the sunlight shining on the water here. Right? If you're looking at the reflection, sorry, I drew it above the water. This person's going to see the reflection of the sun here, and this person's going to see it over here. But you're saying that they're the same sun.
Well, everyone's going to see their own individual sun rays anyway. We know that from sunbeams on the ocean and also crepuscular rays. Everyone sees their own individual ones. It's like it's a unique feature that no other light source in the world can reproduce. And you're like, oh, is it?
No, every light reproduces that.
It produces unique crepuscular and anti-crepuscular rays and unique sunbeams. It doesn't illuminate the whole entire area that it's illuminating.
It does, but you need to show me an example of.
It doesn't do that at all.
But if you need to show me an example of us looking in a certain direction, so let's say we're looking at this as a wall or something, and we have to both see the same light moving in one direction, but we see it go in opposite directions. That's what you're saying happens. So we have to then say, which doesn't happen like when the sun's setting or something, we would see the light come to our feet at the beach, but it would come to each person. We don't see it going in different directions. Everybody sees the sun go in the same direction.
Based on where the observer's at, the sunbeam comes to
Okay, that's a good point. So let me show you what you're saying now. If we had the equator here, let's just say, and there's somebody in the north and somebody in the south, and this person's looking out at the water watching a sunset, and this person watching a sunset. This person sees the sun going this direction, okay, and this person sees it going this direction. So now you're saying that that's because of it's an apparent position, and everybody sees their own sun. So what? Mm-hmm. Tell me why did it when we crossed the equator? Why would this change?
I have no idea.
Well, I'll tell you why. So you have to explain it to me.
Well, see, so here's the thing. You could tell me why you think it is, because Earth's a sphere, is what they would say.
Not what they say, but that's the only shape that actually predicts this. There's only one shape in the world, Alan, that says, oh, if you're on this shape, guess what? You're going to see the sun go in two different directions because you're standing opposite each other.
And if the shape of the ground was what you think it is, then there would be 4 million meters of deviation over that 7 million meter line.
Okay. You keep talking meters. I don't even know what we're talking about there. I'll go back and watch this again and get the actual measurements in miles so I can see what you're saying. I don't know if you're talking about something close or far away. Don't even have an idea. So, I'm serious. I don't know what you're talking about. So I have to.
It's far.
Yes.
So,
but listen, I see what you're saying about the deviation. So I will find out.
We're having.
And here's what I'll say to you. I'll say to you, if the Earth is a globe, then it must happen like you think it should. So I agree with you. So I'll find out why either it doesn't happen or it does, and you're mistaken. One or the other is true.
God bless. That was a main goal of mine.
Okay, well, here's what people should recognize about me. The difference between me and another glober is that I'm still open to it being flat. Very open. In fact, I prefer it to be flat. I would like it to be flat tomorrow. Be great to get off the globe hill. However, for me, I cannot do that because in every instance, the globe predicts what I see. Okay, so if you're bringing up something that you say here, Jaron, does the globe predict what you see here? No, according to you, it doesn't. But I'm not going to just go along with you. I need to follow up with that. So I'll follow up with it because it is something that needs to happen on the globe. If you're saying it doesn't happen, I want to figure out why.
No, fair enough. Because that was a big part of why I wanted to come on too, because I know a lot of the globe audience is going to watch this. Most of them will hand wave dismiss it, but there will be a few math lads that will look at everything, ask questions, and want to.
Good. That should be the goal. That should be why we have these conversations, because we should be able to get past some things. That's why I asked you those 3 questions at the beginning, because it's no use in me talking to people who want to say I didn't go to Antarctica, who want to say there isn't a 24-hour sun down there. It's not worth my time.
Bro, the only reason I could argue this in good conscience is because the Celthio measurements did not go the globe way. Like, I was prepared to, like, when the FTFE thing happened, or I'm sorry, when the TFE thing happened, and we were all like, oh, we didn't expect that.
Yeah.
I wasn't going to argue for it anymore until Mike proposed the null hypothesis argumentation, which was pretty good, but it still didn't quite, feel as good to argue it.
Right.
But then the Celthio measurements show that the conceptual model is, which is predicated on the physical elevation change, doesn't occur at all. And that's so significant. It supersedes all of this to the point where I'll look you dead in the face and say, I don't know why when you cross the equator, you see it, you arc in Antarctica versus, when you're on the north side of it. But what we see is individual to us, and then obviously latitude dependent. And the reason I keep saying that is because we're told, through a lot of the argumentation that we do with other people, is that like latitude dependent effects are mutually exclusive to the globe. So it's just, I just kind of like.
No, I mean, latitude dependent, I guess for me, that just means that it depends on the latitude of what you see. Well, of course, that nobody claims that it's not that. Nobody says, oh, it doesn't matter what latitude you're at, you're going to see the same thing. No, if you're at a different latitude than somebody else, you're going to see something different. So that's why you keep saying that. I'm like, it's like saying, and it just filler words.
It probably comes off as like redundant, but a lot of the people that we argue with are trying to say that, like that alone is mutually exclusive. And it's like, if we see it in the same curve, right, then it would be identical, but they're
Right.
But anyway,
okay. So that was, I wanted to show that because I think what's crazy is before I went down to Antarctica, somebody would have said, hey, I'm going to blindfold you and drop you somewhere on the earth. Would you be able to figure out where you're at? I'd be like, no, I wouldn't have any idea even where to start. But now if you blindfold me, drop me anywhere, by the sunset, I'd be able to tell you whether I was north or south and how far north or south. And then by the stars out, I would be able to tell you exactly what latitude I was at. So it's just like way different because now that I understand how the sun works. And one way to describe what's kind of weird is if you take, let's look at the earth. I know it's weird because it's going to be saying it's flat. So let's say the earth is flat like this. Okay. And you have here, we'll say this is the South Pole. Oops, a little different color. This is the South Pole. This is the North Pole. And this is the equator. Okay. So what's crazy is that if we look at the arc of the sun, let me grab like this. Let me do this ellipse, I mean. Yeah, oops, not that one. This one. Okay. So this is the path of the sun. Okay, so here at the equator, this is what you would see. Okay, the sun rises up from the east and sets in the west. Okay, great. And then as you move either direction, so if we move to the south, all you get is oops, sorry. So we're doing sun, rise and set this way. Okay, so then you go to the south and you just, oops, how do I move this whole thing? There it is. Okay, so as you move to the south, it would start like that, right? And it would keep going like this. It's just going to keep bending. So as I flew south, I saw the sun unbend like this. Oops. Damn it, I knew it was going to do that. If you don't grab it, it marks it. Okay, so then you have this here, and you'll notice that at Punta Arenas, where we were, it was like this. It was super tilted like this, and basically went under the earth like that. So we're here at Punta Arenas. We're looking, the sun rises here, sets going this direction, which is crazy to me because it needs to go over there. And Australia is over there to the right, not over here to the left, but the sun went down over here. Then when you go further, well, the sun lifts up until guess what? You see this. Now all of a sudden, you are far enough south that above you, the sun just does this. Okay. And then if you're like, oh, I wonder what it looks like in the north. Well, yeah, 6 months later, because the sun moves back over there, you get the same thing over here. So the north 6 months later is going to be like this. And then you just bend it the other way. Now all of a sudden, 53 degrees north is going to be the exact same thing I saw in Punta Arenas like this, only on the other side of the earth. And so that tells me that the earth is symmetrical. The north is the same as the south. It's the opposite. And when you have a model that says, yes, here's the model that shows you that the north is the opposite of the south. Here's the model that tells you that, yes, at the equator on the equinox, you're going to see this. Then you're going to, so as soon as you got dropped somewhere with a blindfold on and you saw the sun setting like, let's say this direction like this, you would be able to know, oh, I'm about mid latitude because it's not going to be out bent and it's not going to be straight up and down. This is about a 45 degree angle. You would know that you're at about a 45 degree north latitude. So the earth is like, tells you the shape of the earth. The sun tells you the shape of the earth. You don't need NASA. You don't need Haversine formula. You don't need all these crazy, you don't need stellarium. You don't need to erase refraction. None of that. You can tell the shape of the earth simply by watching the sun, period. And the sun goes the opposite direction once it's in the south. Well, this is the model that tells you why. The model that says that you're on a globe and that as soon as you flip, so again, if you drew a globe here, I don't want to do it real quick, but I'll just do it for a second. So if you have a globe here, and you have somebody standing here and somebody standing here, that those two people are going to witness the sun, even though the sun's going the same direction, you're spinning the same direction, whatever one you want to believe, those two people are going to see it moving in opposite directions. So there's a model that explains and describes what we see. And so to refute it, to me, like you said, I would need to find parts of this model that don't match reality. For me, I cannot find that anymore. Now, you might say, well, Jaron, you've measured curve. No, not really. But I don't think I should expect to. I think that's pretty hard to measure curve on an Earth the size of our Earth. So I don't expect to measure curve. Now, I have measured it if you're talking about my rocket launches. I'm 188 miles from Vandenberg. I can film the rocket launch. And when I go back and play it back with the live stream, I don't see the rocket on my horizon for 1 minute and 5 seconds. Count right now to 65 seconds in your head and realize how long that is from the point of time a rocket launches until I see it on my horizon. If the Earth were flat, I would see it quickly. Not 1 minute and 5 seconds later, but guess what? When you do the math on the minute and 5 seconds, you figure out that the rocket's 34,000 feet. Then you go look into it and you're like, oh, the curvature of the Earth. Oh, guess what? Vandenberg is 34,000 feet below me at the 188 miles. So that, and it's actually.
And if things like sorry to interrupt, but like,
no,
if things like that, if things like that were true, then the celestial theodolite measurements would show that curvature. Like the whole, like, you know, how do we determine curvature and all that? That's what the celestial theodolite makes terrestrial measurements with respect to this, with respect to the stars. Like literally, showing that there's no elevation change. Like what you showed earlier with the sun at different seasons and times a year being at different elevations and locations.
Wait, what did I show? Sorry, hold on. What did I show?
Earlier when you just showed the tilt angle for the sun based off of where you're viewing it from and what season it's in.
Right.
So if all of that is based off of the apparent position, that's why I'm saying what I'm proposing is unique, because this goes off the true positions and there's no physical elevation change, which is absolutely required if the Earth is truly a globe.
Okay. And so you're
Just
saying that,
looking
but
at
does
the
the globe
sun, you
not
can't-
say? Does the globe not say that is where the sun is? I mean, so in the globe Earth, I can pretend that the sun is real.
Not for the true positions. So if
Well,
you were,
true
if you
enough.
were arguing with that, if you were arguing that, then the true position would also be following the same arc as the apparent position, but it actually doesn't in reality. That's the significance of the deviation between the two. So we could see one as a conceptual model, and the other one is like we could see the deviation from the conceptual model from what actually happens.
But you're saying, so on a globe, where are you saying the sun actually is? Then it's never where it says it is. So, for instance,
Even they agree to that. Yeah, it's always apparent in both models.
Okay, but it's apparent by like off by a degree, where yours is off by 180. Big difference. Big difference.
Bro, what?
So you're telling me what is the biggest deviation? I'm sorry, what is the biggest deviation of the sun?
You keep going back to the God's eye view version and saying that it's like a singular source that both people have to be viewing to wrap around.
I believe that the sun is a physical item. Hold on, I believe based on Melodome's work.
Bro, can I just? I'm almost done.
Go ahead. Go ahead. You're saying
I'm trying to get back to where I was. Just give me a second.
Okay.
You're still going off of the. I can't even get back to it, man.
Okay, but hold on. So you said I'm going off of the idea that the sun is a real item.
Yes.
Okay.
Yes.
Go ahead.
Bro, Mello's dome work is kinematics. The whole globe model was built on watching the sun. You're not going to find a contradiction in sunspots throughout the seasons based on that. That has nothing to do, like looking at sunspots has nothing to do with the shape of the Earth.
Okay, so on the globe, which we're looking at now, I'm standing at a place on the globe, I'm looking west, and I'm seeing the sun set. I want you to tell me, where is the sun really? If it's not, so you're saying it could be anywhere else.
No, I'm not saying it could be anywhere else. I'm saying it's following a circuit around us at the equator where it has a 90-degree GP for people.
Okay, but hold on. Let's pretend that
hold on. Let's not. Let me just finish the thought.
Oh, I was talking. I was finishing.
And people, you just asked me to answer the question about
Go
where
ahead.
I think the sun's at. And in the middle of doing that, you interrupt.
Go ahead.
So
you're talking about the sunset. You're saying that it is. I asked if it is where this sun is when it's setting.
Yes. So what we're looking at here, the true position is just following a circle around us. What we perceive is the arc and the antarc and all of that. That is that is latitude dependent for the observers. That's why I've been reiterating this. So when you go back to the God's eye view of it and you're like, well, if an observer is standing here and the sun's over here, how can they see two different suns? It's like you keep
you're telling me that that's reality. You're telling me that you keep saying a God's eye view, but there's no problem of taking a God's eye view of reality. Who cares? It's just I'm getting above the Earth.
No one's ever seen it, and you're merging two conceptual models based off of apparent positions that don't truly change in physical elevation.
No, I'm asking you. You keep going back to that. I'm asking you. Let's just go simply, not go difficult. Let's just say simply. Can we get above the Earth and look down at it?
No.
Conceptually,
no. We can't. No, not even
what?
Conceptually. What would be the purpose?
Because I'm asking you a question. Like we need to know the layout of the continents. Do you not agree that they are the AE map layout?
Yeah.
Okay.
I'm sure that it resembles something like that.
Me too.
But what we use to navigate it is two hemispheres of stars merged together.
Okay, but I'm not talking about the hemispheres.
Based off of them saying that there's a.
Here's what I'm worried about: is when I was in Antarctica, I was looking south, knowingly looking south, and I saw the sun. Okay, that completely destroys what we just said about the flat Earth. It cannot be I'm looking down at the Earth and I see the sun south of me in Antarctica, because guess what? At that exact time, it's above the people's heads in Australia. So you need to explain to me if I'm either supposed to believe that what I saw to my south was some figment of my imagination, even though I felt the heat from it. The heat was coming from the sun. So therefore, it can't be some apparent position. It could be an apparent position that also generates heat, I guess. I'm not confused how that would even work. But the real sun is 30,000 miles behind me. So guess what? On the globe, I can pull up the globe like this, and that sun that I see, that's the only sun. Nobody else sees a different sun. That's the sun. I don't need a mystery sun. I don't need magic suns. I don't need refracted suns. That's the sun. And if it's above the people's heads in Australia, guess what I know? Australia's on the other side of that ball. That's what it must be. It's easy.
A physical elevation change for the sun as
well.
Okay,
I'm glad you keep going back to that because I've already told you I will check into that. So you keep saying that, and I'm hoping that it's as solid as you think it is, because if it's not, you have to be a globe earther.
I know, because you keep going back to the apparent position and reconflating it. Like, we could just call it.
There is no reconflating. There is the fact. It's a fact that in the south, people look south to see the sun, and it's the same sun that the people in the north see. Okay. So
I don't. The only thing I disagree with is that it's observer dependent, like individual to them. It's not the same one that you're looking at in the sense that you think it is, that you could like draw a triangle to a physical object.
Okay, but if you're looking at it and it has sunspots on it, then the other sun as well has sunspots in the same spots, right? So now the apparent sun carries the sunspots of the real sun. And how do we know which one's real and which one's not? We wouldn't know.
Wouldn't know.
Yeah. Okay. So that's what I'm saying. So really what I'm being left with is there's two different models for me to choose from. One of the models where I can say, see sun, there's sun. Okay, good. I get the sun. The other one is anything can go. I don't know what the sun's doing. I don't know if there's multiple suns and they all have the same sunspots, but I can't call them the same sun or else the Earth's a globe. So, I mean, anybody who's at this point stays a flat earther is very, very, very open to the ideas of magic and mystery. And even though you have to then believe God is a deceiver, because God made the world that answers every question by saying sphere. That's it. Answers every observation we make from the ground, except for the one that you brought up. So I'll put that in there. If Alan's right that there's an observation, then I can no longer say that every observation that we make of the sky matches the globe, because according to Alan, it doesn't. But I haven't got to that point yet. I'll report back. But if it does, then every observation matches the globe perfectly. The globe describes everything. The flat earth doesn't describe anything. In fact, it requires you to believe that the sun could be anywhere. We don't know where the real sun is because, yeah, you might see it in the sky, Jaron, and it might be heating you up and it might have a hot spot on the water, but it also might be above Australia's head 30,000 miles behind you. So you just have to, whatever. I guess it's just mystery. For me, I don't like that. That feels very weird. Whereas the globe, yeah, it feels weird because I don't feel like I'm on a globe. I don't feel like I'm spinning around. I don't feel like I'm on a ball. However, if it answers every question and every observation I make, guess what? I live on a ball. Period. There's no way that it could answer every question. And actually, the truth be that God just deceived us. He said, I'll put this sun here and make it look like it's a ball, but really, it's a magic refraction, double-sided, double helix firmament dome that happens to just make magical qualities where the sun appears wherever it needs to be. And it just so happens that the sun happens to be where it would be in a globe. It's really weird. Really weird.
Can I comment real quick?
Sure, go ahead. You let me talk.
God deception thing?
Yep.
Okay, so I don't think that's necessarily the case. When I looked into the history of Japanese cell nav and Chinese cell nav, what I found was they actually invented celestial navigation. They invented the celestial sphere. They went to the south, mapped the same thing. They had their own way to determine latitude based off of shadows produced by the sun throughout the day and year. And then they also came up with a ratio for when they would change in length to determine latitude. So they had a whole system for all of this. They had a whole system for categorizing stars as they transited over the Beijing meridian. And they actually changed their cosmology from being geocentric flat earthers with the kind of like conceptualizing it as a square. They actually changed it to being rounded because like the way that they see is still flat, but they changed the way that they talk about the heavens and stuff, because what they realized is that the heavens that they see, the celestial bodies that they see, aren't real. And it's like they were talking about it as an illusion, and like it's an apparent thing. It's not physical. So their whole cosmology was based on knowing that what you see in the sky doesn't represent physicality, and that you don't actually see that, and that there's a limit of vision. They actually derived everything that we're using right now for cell nav to the direct equivalent, because what happened in the 1600s is the Jesuits came by and basically stole their whole methodology and then reproposed it as it was derived from Greeks, with all this missing history where there's no firsthand information. Well, there's firsthand documents from like all the Chinese stuff where they invented trigonometry and all this stuff.
You need to talk to Austin and remind him that him and I found this paper that was written by some Japanese guy in late 1800s at one of the world's fairs. And in all the documents we can find, it says that he had a working model of the flat earth, and that it was based on ancient Japanese or Chinese, whatever. and it was a working model that everybody could go see at this World's Fair. And no matter what we looked at, we could not find any description of it. Oh, you did?
Yeah, I'll pull it up real quick. I'm screen sharing.
Are you talking about this same kind of people that are doing? You found it. Where did you find it? I know we couldn't find it.
So somebody linked it on Telegram, like the image of what it was, and I didn't know what it was specifically, but I was like, oh, I'm pretty sure I know what that was. So I started started the investigation, and I found it. Give me 1 second.
Right, and it was the guy who displayed it at the World's Fair, right?
Yes, sir. Yes, sir.
Yeah, because I would like to see that, because again, what the difference is, what you're describing when you said it's based on longitude, latitude. Well, longitude, latitude have the North and South Pole. So I can't really picture a flat Earth person or a flat Earth group using longitude, latitude, because what it means is that 0 degrees is in infinite places. 0 degrees, 90 degrees south. Sorry, it's not 0, 0 would be the equator. And 90 degrees south would be an infinite amount of places, right? Because it's that entire circle. That's what's crazy about when like Duffy asked Flatzoid where the South Pole was. Because, oops, what am I doing here? Clicking on OBS instead of this. When he asked him where the South Pole is, because the crazy thing about this map is that the South Pole is everywhere out here. This is the South Pole. Even though it's one spot, it's all these spots. Everywhere.
Yeah, but that's a projection of the coordinate system. So like that's not, it's fine, dude.
Right, but I get what you're saying, but you're not allowing us to understand what the real world is. So I understand that this is a projection. Okay, great, we can say that. But I think that the world has to have a real shape. Meaning, if we really got above it conceptually, wouldn't it look like this? And the answer is yes, if the Earth is flat.
I agree. It does look something like that, but we use a coordinate system derived from the stars from our position on the ground.
Right, but we use the distances. We use the distances based on that as well. Meaning that if you find two places in this near the South Pole, their distance would be very close to each other. However, these two distances would be 40,000 miles away.
Well,
yet in real life,
distances are going to be internally consistent because a meter is a ratio of the terrestrial meridian itself.
Correct. That's a globe proof.
What?
You just
it's a ratio of a coordinate system, bro. It's not a globe proof.
It is, because the coordinate system is a globe.
The coordinate system is spherical.
Yeah. So you're saying that the distances are matched. Of course they match, but they don't match this.
When we both talk over each other at the same time, it's super productive. Let me tell you about this model real quick, and then I got to dip.
Okay, I got to dip too. Go ahead.
All right. So here we go. This is what was found here, and what we see.
Oh, sorry. Let me bring this up.
Sorry, yeah, we see the equatorial plane and we see the celestial here. You see these domes here. These domes represent how you see the heavens, and they're separated to represent 4 different continents. The way that they conceptualized it is that there was like a localized dome over the continents that projected the stars in the way that they see it. And what they have over here is a central axis that extends up. The way that this works
does that cause the eclipse?
What?
I wonder if he says that it causes the eclipse. It'd be, could be that the sun goes behind there and then it just flashes. The light wouldn't get across; it would block the moon. Go ahead, anyway. I mean, it would show the shadow on the moon.
Bro, this is a fucking conceptual model to hold up things that are dangling that reflect
light
on the mirrors that are here. So it's just
okay. Go ahead.
So there were strings attached to here, like little chains, and they had gemstones and different metals on them. And then you would shine light on them so that they would be reflective. And then inside of these little areas here, these were little glass domes that have latitude and longitude on them. And the celestial bodies, as they go in a circle above us, get displayed as different arcs. And then as this was set like as a planetary gear ratio, where once it completes 90 turns, it's basically changing in elevation as it's going up and down. So what you'll see is the positions of the celestial bodies change in the reflective dome here, creating a north and south pole. They had all of this all mapped out. So like when you translate what all the stuff means here, this is like they knew all about this, and they didn't change cosmologies to be globe lads. Like it wasn't until like the late 1800s, about 200 years after the Jesuit influence, did the Chinese change to being globe lads. They had a whole system of navigation, latitude and longitude. Yeah. That's completely identical to what's used today.
Right, but I mean that wouldn't ever be able to match reality because again, they were the first people to sail around the world. Okay, I didn't say I didn't say you can sail. It doesn't. You can have a model that you've brought up 2,000, 3,000 years ago that allows you to sail the Earth. It doesn't mean that it's the correct model of the Earth. So when you go back to that model, How could you have stars that are circumpolar, like we looked at earlier in the south, on this model? It's impossible, Alan. It's impossible.
It's not impossible.
Oh, so show me how jewels are going to hang from those strings that are going to then circle the South Pole when they're on the other side of that little stick.
Listen, whether or
Show
not
me.
it's possible to demonstrate or not,
Right.
the Chinese did it, mapped it out.
But that doesn't mean we live there.
It works.
I don't understand what you're saying. Let's say
Dude,
somebody.
it doesn't mean that we live there. That they merged it together, and you can do it now.
You cannot make the stars do circumpolar around the South Pole star. You can never do that.
No, nobody needs that to happen, bro.
That's what happens in reality.
They literally invented the celestial sphere in the north and in the south, mapped it together. You think they weren't smart enough to go, oh, you know what? This probably means we live on a sphere. 200 years of Jesuit influence before they accepted it.
Right. So why didn't they find it? They just said, okay, we'll just go along with these guys that are telling us things that aren't true.
Using the same system. Yeah, basically.
Okay, well, that doesn't make any sense. People who came into a observatory and said, hey, this is the actual truth, they would go, no, it's not. This is the truth. We make better observations. Guess what? They came in there and they made better observations and better predictions, and then the Chinese said, it's a globe.
Name the better observations.
I just told you.
There was, no, you didn't. There was a 13-second.
Is there circumpolar stars in the south?
They used these circumpolar stars to navigate in the south. They mapped them out and made a whole latitude longitude system based off of eclipses.
Right, but this model doesn't work on that. How are you going to make stars circumpolar in the south?
This isn't the model that they used.
Oh,
number one.
Okay,
you asked me about a thing that was in a world fair, and I told you what it was and told you how they said it works.
Right, and I was hoping that it would explain things, but it doesn't explain things because that cannot work with what we observe in the south.
Well, bro, you haven't even seen the dangly stuff on it reflecting at different altitudes. So I don't know if it does work or not, but that's what they said. This is what it was based on.
And that thing turns once a day, right?
No, it turns however you turn it, however many times, however fast you turn it, and then it's set on 90 degree or 90 turn intervals, so it raises and lowers in elevation per 90 days.
Right. So 1 day is one turn. So I'm just saying that the stars that are on the inside of that disk at the top would be the northern stars. The ones on the outside of the disk are going to be the outer stars, but they go all the way around the outside. Yet in the little dome down there, it only can go around the other side, and they have to stay within this Sigma Octantis, which just isn't possible. It's just not possible. So
it's not possible. Yeah. All right.
Yeah, that's all. But I will look into what you said. I will make a video about it or get back with you, and we can have another meeting because I agree with you that the globe Earth. The reason I'm a glober is because I've realized now that it predicts all that I see. So until it doesn't predict something that I see, then I can have a problem with it. So for now, it does. As far as the sun and moon, that whether they're upside down or not, whether they're moving in which direction they're not, everything matches the globe. And then the other thing is, I've never found anybody who has been able to debunk Google Earth. So Google Earth places everybody that we know on a sphere and shows them what their observations would be. So one person out there better be able to say, Jaron, I live at this location. I'm looking at what Google Earth says the sky will do, and it's doing something different. And you won't find that. And so where does that mean that we live? You guys want me to believe that it's possible for them to place us all on a sphere, and our observations match everywhere on the sphere, but we're not really on a sphere. And if that's true, then just show us another version of something that matches the same thing, but you'll never do that because it's impossible. How could you show something that matches the observations of another place, even though it's a different shape completely? It's just not going to happen. But go ahead, tell everybody where they can find you and how they can get more information and where they can do that themselves as far as the cell theo or whatever you call it. What is it called?
Yes.
Oh, I have to read the rest of it.
The celestial theodolite.
Sorry, so can you stay for 5 minutes if I rush through these super chats? I just want to know if there's any questions for you. I'll get past the ones that aren't for you. So for the eclipse simulation, did Alan account for the fact that the personal dome would cause each observer to see the sun and moon at a different position in the sky?
Yes.
Okay, I would think so. Okay. Yes, the answer. Thank you very much, Pink P. Floyd.
It's based on the angle that the observer saw it at, and then the distance of the triangle.
Okay.
Yes.
Mr. B6034 says, Alan, is it possible that you have a mistake in the calculations that you have made in your celestial theodolite?
It's highly unlikely.
Okay.
We're at 24 weeks of celestial theodolite updates. No one's refuting the math. It's always like trying to attack the methodology or the analysis.
Okay, we got Sick Doctor 1 says, how is it that now you can use the lights in the sky to determine the shape of the Earth? Well,
I was never bound by any sort of dogma, and the entire globe model is laid out based off of looking at things in the sky in the apparent positions. So the best way to refute that would be to find a way to show that the true positions don't change in elevation and that's always apparent. That would be a good start. So that's why we went with that. It's dogmatic as hell to say don't look up at the ground, because a measurement without an external reference is just circular. So like if you were to like if you were to build like a force the line situation that's literally attached to the earth that could exist on either model, doesn't prove either. It's like using a ruler to measure itself. It's retarded.
I agree. Okay, good. We've got from Jesse says, looks like a globe, but it's just an illusion. Yeah, yep. Okay. Science Minded says, see email for printable model for Allen, etc. Simple geometry of 6 airports. Wait, Science Minded says, see email for printable model for Allen, etc. Simple geometry of 6 airports. Okay. Jesse says, Allen lied again. The difference between flat and globe is 25 miles, is 400 feet, and easily distinguishable. His method fails in a lot of cases. Okay. We've got fake super chat for $420. Thank you very much. I do appreciate fake super chats. My favorite. Only 4 left. Galaxy Soup says, can Alan explain why never in recorded history have we seen the sun's angular size change over the course of an entire day from sunrise to sunset, confirmed simply with a solar filter? Well, it does change maybe a small, tiny bit, but not nearly what it needs to. Do you have an answer for that?
Yeah, my answer is that if we don't see the physical sun, what we see is an apparent object.
Okay. We've got Sean Hawkins 666. Alan, Antarctica isn't named that because of its Antarc. It's because there are no bears there. Arctis is Latin for the bear. Okay. Jesse says, by answering it's just apparent position to every globe evidence, Alan's basically conceding that according to our senses, Earth appears to be a globe. Huh? I mean,
sorry, what did you say?
He says, by answering it's just an apparent position to every globe evidence, Alan's basically conceding that according to our senses, Earth appears to be as a globe. So you would say that
that's my premise. The whole globe was constructed from watching the sun and the stars. We've done tons of presentations on it. Like it's our premise.
And Pink P. Floyd says, Alan, does the apparent sun provide apparent warmth or real warmth? It's a good question.
Ooh, great question. There is a huge asymmetry in the climate in the south versus the north in terms of being directly at the poles or whatever. So
yeah, well, one's water and one's 10,000 feet high. It's a little kind of different temperatures there at water level or 10,000 feet high. Different atmosphere. Okay, that is it, I think. Thank you very much, Super Chatters. Do appreciate that. All right, now you can say your final word and where they can find you and get more information on the Celestial Theodolite.
If you want more information on the Celestial Theodolite, you can go to publish.obsidian.md/space audits and click on the Celestial Theodolite section, in particular the bounty section, if you want to learn how to participate. Like I said, we do have a prize pool so we can get some more terrestrial measurements. If you want more information about the eclipse, click on the eclipse tab. You can see the PDF that Brian made for us. He has all the math and everything laid out. And then in the comments, there was a couple of comments from some people on YouTube that had questions about the data and all that. The PDFs and responses to those questions are in the documentations here. If anyone has any meaningful, substantial refutations to the math or the process that we used for the eclipses or the Celestial Theodolite in general, just send me an email with your critiques. Doing it in PDF format would be preferable. That way we can go over, individual points and go point by point and stuff. If you want to join the discussion and talk to us about it or whatever, we have a Discord channel dedicated to it. It's called the Cell Theo, but you can find that on our Discord. That's discord.gg/ethercosmology, and that's ether with an A. And if you want more YouTube stuff, my YouTube channel is at @space_audits. You can go there. We do Celestial Theodolite updates and discussion every Monday at 8 p.m. Eastern. So if you want to discuss the Celestial Theodolite, you can go to, we actually do that on Earth Awakenings. It's a more public server because we've banned a lot of people from ours, but we go to a public server and have our update there. So anyone's free to ask questions and stuff, et cetera, and go over the data. Sadly, there's been a lack of participation on the globularist front, and everyone's relying on our boy Jesse over there to disseminate all the information about it.
Yeah, no, it'd be good if some people did look into it and at least, get to an answer there. Because again, if we can start to show some of those things to be false, that Alan's saying, Alan even said, if you can show that change in elevation, then he sees no reason to remain flat. So it's something we should work on, and at least, or at least I need to know. God, I guess in my eye. At least I need to know why it is that the observation is not matching the globe, because I'm under the assumption right now that there isn't any observations that I've seen or heard of the sky that don't tell us that we live on a sphere. So if we don't see an elevation change from each person, then there's a problem. God.
And not only did it not match, the globe, so-called, it actually contradicted the Kepler/Newtonian distance that they give, which I don't know if you're familiar with all that stuff, but it's basically how they derive the distances to all the planets and stuff. It's just a ratio of how long it takes to complete a circle.
And I've said that before, right? Yeah.
Yeah, over the time it takes to complete it. So the distances could be anything, but they're set on what was calculated from Kepler, and then they can also derive newtons from that. And because they're using big G and big M for that, they're asserting like, okay, it must be this distance, therefore, and that based off of this mass, there's this much gravitational potential between them to cause this velocity over this distance to complete that circle. So it actually contradicted that as well.
Okay, gotcha. Any final words? Anything else you want to say?
No, that's it, man. Thank you. I apologize for getting heated.
Me too. Happens.
I probably gave some snarky looks and stuff at you.
It's all right. I'm okay with it. I'm accepting it. All I care about is getting to the truth. I feel like I've already got there. So at this point, I have to be ready to, take people coming at me with apparent disproves or debunks of the globe. So let's see if they happen, if they stay up, or so Jesse can still ask questions and y'all answer. That's from Icy Spin.
No, you can't actually ask questions if you're on screen showing the equations, going over the math, been given several PDFs in the same time that you're saying that you haven't been given the math, and saying that it's a different math equation, even though a new equation hasn't been shown to be where it's different. Like, you can't just lie endlessly and I'm still going to talk to you. That's literally retarded. I'm not doing that. If your answer is just to lie and obfuscate, you can't participate. And that'll be determined. And that was determined over the course of like 15 episodes where we gave Jesse unlimited time to speak and answer all his PDFs. We even did the PDF exchange program with him because the stuff he would start critiquing was just ad nauseum ridiculous nonsense that had nothing to do with refuting the actual null hypothesis or showing how the elevation change is being physically demonstrated for the globe. So if you're not doing that, then you're doing something. If you're not doing that, you're doing something else. And if you're doing something else, you can do your own presentations about the thing that's not what we're doing.
Okay, I just love liars in the chat. It's my favorite. So this person says here, Jaren bans anybody who disagrees with him, which I have not banned anybody. I don't ban anybody from YouTube. So if one of my mods did, then you'd probably have a problem with them, not me.
I'll say this. I often ban people I disagree with.
So he says, once again, add Jesse, once again a liar. Plenty of Globers on Ether cause, just not liars like you. Jaren actually bans anyone who disagrees with his recently found retardation. No, I don't. So I don't know what you're talking about. It's recently found retardation is so funny. It's just funny to me. I'm supposed to believe this guy in my chat, Galatrix Bear, he's smarter than every single physics professor in every single college that there is. That's what I have to believe. So who do you think's more dumb there? Me or him? It's like, give me a break. This guy's smarter than every physics professor that's ever existed. Same reason why surgeons are not playing Operation at the child care. Nobody wants to give them the view. Oh, sorry, don't know what that is. Just seeing, somebody said I don't look at the chat. So when I'm having a debate or talking to somebody, I try not to, or else I've seen it happen. I remember I was moderating debates and I would see people looking at the chat the whole time, and then they would just be terrible in the debate because they weren't paying attention. They were not even listening to the other person. They cared more about what the chat says, and they even change what they're going to say based on what the chat says. I don't want to do that. So I don't do that.
Same. And you're so right to do that. That's why I don't look at chat either when I'm doing stuff.
Yeah, I've seen everybody, they become who their chat wants them to be. I can name 10 people that are exactly what their chat wants them to be. Rocket launches are just skateboards paying ride to the dome. Oh, that's just a joke. All right, I was just seeing if there's anything else there. So is Alan and Shame at Jeranism? What? Jaren, Alan banned me in less than 10 seconds when I said hello on the Ether Derpology server. I have it on video. Oh, that's from Max.
Like I said, I do ban indiscriminately and for completely random reasons. I have no idea who you are, no idea what you said. If you got banned for just saying hello, you probably said it at the wrong time.
Okay. I mean, it's scary to think about, though, that, I mean, you do realize that is a pretty vicious echo chamber. calling it ether cause or whatever that is, right? I mean, that's what an echo chamber is, right?
Oh,
If nobody really
oh,
bucks a
you're
trend.
gonna start critiquing something that you don't really know anything
I'm
about. or
asking
why
you as a
banned it,
question.
or who
That's
the
what I just
history,
said.
or who the history of that guy is.
No, I just
don't know
asked you a
that, man.
question. I said your ether cosmology is a pretty big echo chamber, isn't it? You can say no, it's
No,
not. That we all disagree all the time, or we.
Sorry, I misheard you. Then, no, we have globe lads on there that disagree and provide meaningful substance advice and stuff like
Okay.
for the math and everything. Like we have, it's a mixed group of people, man. What we don't tolerate is like just outright lying. Like that's absurd.
Right.
The people that do that and waste time and argue endlessly with no conclusion over stupid shit. Like this isn't the place for that. Like. So
Yeah, no, I get it. I mean,
that's-
if somebody has
so-
a direct reference, they should bring it like in a PDF form, or say, yeah, they can come into my channel and present. I don't care, in a condensed version. But you should be able to show why somebody's wrong about something, or why their understanding of it is wrong. For instance, if he's wrong about the drop of the sun and moon or whatever, then should be able to explain it easily why he's wrong. It shouldn't take.
we don't
conversation.
even know what that guy in particular is wrong about.
Yeah, I don't know.
So.
Says I banned
Like,
him.
and that's the thing. Like, doesn't matter. But if like people that are on other servers, right? Because it's a small community. We're all on the same different servers, right?
Okay.
And what people will do is they'll be on one server. You give them an explanation to something, then they'll be on another server and be like, I've never heard an explanation to this. Like, we don't do that shit here. And like, if you behave like that, you can't come and be a part of our community. If we want to interact with you, we go to whatever server you're on and do it that way. Like we're actually doing research, looking for meaningful refutations. If something gets refuted, the argument gets dropped. It doesn't go anywhere.
Okay.
Like we don't, like if you come in and do nonsense and you're a nonsense person, you get shown the door real quick.
Okay. See if there's anything else here. Send your fluids to Alan says he doesn't tolerate lying after spending 3 hours lying. Shame because you can't handle the math. All right. I think that's everybody. All right. Thanks, Alan. Appreciate it. Oh, sorry.
See, like something like real quick, like that's
Yeah.
a perfect example. Just spent 3 hours lying. I just spent 3 hours showing, data of no elevation change, like the significant takeaway from this. But it's like I'm somehow lying about that.
Well,
That's
I'll find out about that. It's going to be one or the other.
Yeah.
Either it was a lie or it's true, and it needs to be explained. So one or the other. So
Yeah.
I appreciate you bringing
you-
that information up because I think it's good. And I think if Globers would have handled things a little differently, maybe this wouldn't have gone as far as it did. Because I do think that, like, if I now just go make fun of Alan and call him a bunch of names, and then I'm not getting anywhere. That's not going to change his mind, and it's not going to change my mind. So instead, I'll take what Alan is saying, and I'll go and weigh it out and see what happens, and then try to bring it back to him and say, this is why you're wrong, or I have to explain why if he's right. So that's the way it should go, rather than just laughing. I get why Globers do that. I get that for the most part, it seems like at this point it's like a foregone conclusion. But I still think when somebody's got a legit reason, I mean, we have to believe Alan. We have to take him for what he's saying, that he said he would be a globe earther, just like I would say before, like, oh, if you show me 24-hour sun footage from the south, I would be a globe earther. So Alan's made the same claim here, that he would be a globe earther if we showed drop in those celestial bodies. So must be a reason why it doesn't show drop. So let's figure it out. That's all I'm saying. Sound good?
Well said, man.
All right.
Appreciate it. It was nice catching up with you.
You too. Take it easy. Later. Guys, what do we have coming this week? Anything else? I've got tomorrow I'll be on with, I don't know if he's recording though. I think he's recording. Does Culture Cats do live or does he record? Oops. I don't know if he does live or records. Jaron, do you believe we went to the moon now, etc.? Do you believe that to be true now that you assume to be false? I would not argue that we did not go to the moon. I don't think that there's sufficient evidence. If you're going to argue from evidence, no. I believe that I've never seen, and in fact, I did 4 shows with Dave McKeegan where I asked the audience repeatedly to send me evidence that we didn't go to the moon. And what I got was a bunch of people messaging me saying, of course we didn't go to the moon. And I said, okay, I get that. Where's the evidence? Show me that. Evidence. It's obvious, man. I mean, what did you call the moon from a cell line, or I mean from a landline? I'm like, what are you talking about? Nobody believes that, asshole. Nobody believes that Nixon called the moon on a landline, you fucking retard. Nobody thinks that. You can patch calls through a radio. You can do that. So this is the problem with flat earthers. That's their best evidence. Oh, what do you do? Look at these guys. They look like their dog died when they got back. I get it. But that is not evidence that works in any walk of life. You can't just say, oh, look at their demeanor. oh, the demeanor proves it. No, it doesn't. The demeanor, we don't know what those guys were going through. Maybe they just got told before that event that they're going to be getting half pay the next year. We don't know. We don't know. So the claim that what I used to previously think, all the reasons that I thought we didn't go to the moon are not good evidence when it comes to evidence that should tell you, like, evidence is pictures, evidence is some sort of and again, what I see from flat earthers is they say we didn't go to the moon, and what do they use? They use NASA's own numbers. They're like, oh, but it says it's 250 degrees and 250. So now you're going to trust NASA to tell you the temperature on the moon, but you're not going to trust that they've been there? Think what you're saying. Think what you're saying. If you don't trust NASA, then you can't take any of their numbers. You can't say, oh, it's 250. How do you know it's 250 degrees on the moon? Wouldn't it have to be the distance that they say it is to know the temperature? Wouldn't they have to know a lot of things? Well, that's the problem. That's why I said if we've been to the moon, then probably a lot of things are true about the solar system they tell us. The thing is nobody's bringing good evidence that we didn't go to the moon. Go look for evidence. In fact, Bart Sibrel lied numerous times in his movie. In fact, Dave McKeegan debunked his whole, oh, they're just in low Earth orbit nonsense easily. And if you didn't see that, that's your fault for not watching my shows. It's your fault. If you didn't watch the shows with Dave McKeegan, then you have no right to tell me that I should not or should believe in the moon landing. Okay? Because you didn't go through all the evidence that we went through, and it was shown clearly that Bart Sibrel is lying. Okay? You can tell that Neil Armstrong is at the window, and then he backs up from the window. So just to say, oh, he's looking at it from the far away, and no, it's not what happened. Go pay attention. Go pay attention. And here's the problem is everybody who's a flat earther or globe denier, you just believe everything you hear from other flat earthers, and there's a problem. They're all liars. I'm talking Dave Weiss, Steve Falconer, you name them. Start going through the list, and now I can show you where they lie. They tell you certain things are seen from certain distances at certain heights. They lie. They tell you we see from this height, and I can see across Lake Michigan, and then you find out that they're at a 500-foot dune. Okay, all these things make a difference. So can you make a case for the Earth being flat if you lie a bunch? Absolutely. Absolutely you can. Very easily. But then anybody who can go out and observe anything in the south will tell you that you're wrong. Tell you they're wrong. So I'm sorry that I choose the model that I can point at and say, oh, there's the sun. Oh, really? How is it above the heads of Australia? Well, it's over there, and that's where they are. It's above their heads. Oh, yeah. Yeah, that's the one sun. Cool. And it goes the direction that the globe tells me. Cool. Yep. And it goes in the season that the globe tells me. Great. And the sunset and sunrise times match perfectly what the globe tells me. Oh, great. Do you understand? How many times do I have to say that until I realize it's where I live? And my only refutation is, well, I don't feel like I'm spinning. Everybody grab something in your house right now. Here's my phone. Spin this once a day. Do you see it spinning? Look at it. Look how fast it's moving. It's spinning once a day. Look at it. See how fast it's moving? No, it's moving extremely very slow. The Earth moves extremely slow. 1,000 miles per hour. Yeah, you're saying 1,000 miles per hour, but there's size, there's scale that's involved. So 1,000 miles per hour to us seems very fast if we're moving 1,000 miles per hour at the ground, and we're moving at, comparable to the ground. But we're on a giant sphere that's spinning 1,000 miles per hour. But if you were in space, pick yourself in space, go up and look at the Earth. Do you think you'd be able to see it spin? You wouldn't see it moving. That's how fast it's spinning. So to think that you would feel something, imagine you're a tiny little ant on a globe that from space you can't even see moving. Yet you think that that's fast for the people on the globe? Think about it. You are in space looking at the giant Earth. It's spinning and you wouldn't be able to see it spin. You just stare at it and you go, oh, I think it is moving. If you looked real carefully, you'd be able to see it moving. Now, do you think that the little tiny ants that are on that ball Earth would feel that spin that you can't even see? Give yourself a break. So you've just believed people over time like I did. I bought into all these ideas. And then once you have a feeling that you're right, and then people start watching you at conferences, and they start watching your videos and telling you you're funny and that they think you're onto something, your brain tends to push things in that direction. Your observations, your research, all want to go in that direction because that's what your brain wants. And it takes something slapping you across the face for you to wake up and realize that you were wrong about all that. And it's not a matter of people always say, are you going to give up those thousands other proofs you had? I never claimed to have proof of the flat Earth. We had lots of evidence for a flat Earth. That's it. We had lots of evidence. And evidence doesn't lead you to the truth always. Again, you show up at a murder scene. There's 6 pairs of shoes. They're all evidence. That's all evidence. The shoes are at the place. They're evidence. Now, you could follow one pair of shoes and go to a dead end, follow another pair of shoes, go to a dead end, or you could just be so convoluted in your head and be getting cheered on to pick one pair of shoes, and then you start going in that direction and you think you're going somewhere. No, this pair of shoes definitely leads. No, it doesn't. once you find the right pair of shoes and you get to the killer, then you'll realize those other things are still evidence. They just didn't lead you in the right direction. So all the things that I said about the flat earth and the globe were all evidence, but they led me in the wrong direction. Do you understand? There was never a disproving of the globe earth. Think about what your disproof is. Your disproof is if there's a globe earth with a radius of 3959 and a circumference of 2491, right? Then every distance to the horizon must be the square root of 1.2, whatever, times the square root of the Pearson's height in feet. Okay, great. The problem with that is that you didn't say at the beginning of that, if there's a globe earth and it has refraction. So you took out refraction, which is the explanation for why you see past the physical edge of curvature. And guess what? I'm here to tell you, you will always see too far. I'm not like the other globers, not like MC Toon that tells people, oh, you don't ever see too far. You do see too far every single time because we don't live in geometry land. We live in a reality where there's an atmosphere. Atmosphere has liquid in it, water in the atmosphere. So any distance that you're looking, you're going to see too far. You're going to see further than the geometry calls for because that's how refraction works. And you can show that. You can prove that. Now, does it lift entire buildings up and stuff like that? No, it doesn't seem like it. It just seems like you, like if you're looking over, say, Lake Michigan, at the buildings in Chicago, you're up at a certain height where, yeah, you see the water cover the buildings, but that's because that's the curvature of the earth. So what was the answer for a globe, for a flat earth? I don't think you ever had one. We just had to say, oh, well, it's because of ramping up or something. But think about it. You're looking across Lake Michigan and the buildings are half covered with water. So what is the flat earth explanation for that? Right? Where the globe earth says, and it works mathematically, that's because of the curvature of the earth. And then you have people say, oh, well, if you watch a time lapse, well, watch a time lapse and you won't see the water move up and down the building. So what is that? If you want to see, I mean, the best thing that you can look at, and this actually convinced somebody, by the way, if you don't know, I don't know if I'll be able to find it right now, but if you look up the turning torso, somebody actually messaged me and said that this convinced them. I brought it up just in random at one of my shows, and the person's like, oh, now I'm a believer. Oh, that's great. Is it? I wanted. So this shows you, this person went out and took the turning torso, and then he just keeps moving away from it. And as he moves away from it, the water just gets higher and higher and higher and higher on the building. Exactly what the globe earth predicts. So to just believe it's flat and that magically water covers buildings over distances is not very smart. It's just not. So you can, everything that a flat earther believes, and if you're a flat earther, let me just tell you something. In the next coming years, be it 5, 10, 15, you're going to realize how dumb you were. How do I know that? Because if you ask Melodome, ask Patricia Steer, ask Robbie Davidson, ask anybody that's been on the WWF show, ask myself, anybody who has come out of the flat earth realizes when they get out, they go, oh, fuck, I was dumb as shit. Oh, shit, I looked at every evidence and I was so biased that here's the other thing. Let me tell you this. I was watching last night, Whatcast had a show, and it was me and Austin debating Will Duffy. And this is January of last year. Will Duffy said things that I know for a fact I never heard. Why? Because I blocked out anything. Not knowingly. It's not like I knowingly did this. It's that your brain is blocking out the information that will tell you that you're wrong. So I know what I'm saying now is not going to register with you, because if somebody said this to me 2 years ago, it wouldn't have registered with me. But you've got, Duffy showed eclipse paths on the flat earth map and showed that in the south, they're way longer because the flat earth is expanded. And again, if I was, I mean, like now I look at it, I'm like, oh shit, there's another evidence. There's another proof of the globe. And yet at the time, I didn't even hear it. And it wasn't because I wasn't listening. It was because your brain blocks it out. So anything that's being said that's going to take you back to the globe, your brain's blocking. It does not want to lose all your new friends, lose all your new, oh, you're so cool. You go around and you get to tell people that went to college how dumb they are and how smart you are and how indoctrinated they are. And you're not indoctrinated now. You know the truth, man. You know the truth about everything. Charlie Kirk wasn't killed at all. It's all the stage. The world's a stage, man. We don't know any truths. Everything's anywhere. The sun can be anywhere it wants. That's nonsense talk. The sun is real. The sun is physical. I hate to tell you, the earth is real. It's physical. You can measure it. We can get above it and look down at it. Do you understand? Even conceptually. So what Alan did today was just tell you, well, yeah, I mean, it's not the map. It is the map. It is not the map. It kind of is the map. And really, no, it's not the sun. The sun's over there. It could be over there. And it could be there. Well, but it's all latitude dependent. That's just bullshit talk. You can either fall for reality or you can fall for bullshit. I'm telling you, you've all fallen for bullshit. And was I responsible for it? Absolutely. Was I at the head of it? Absolutely. Now, did I know it? No. That's the sad part. That's the part I'm trying to get across to people is I understand why flat earthers remain flat earthers. And science should recognize that some of the things that really cemented it for me are the things that Stephen Hawking did, faking his stupid experiment. Nat Geo did, faking their experiment. Not smart. Not smart. But regardless of who fakes experiments, it doesn't change the shape of the earth. It doesn't change the shape of the earth. And I can't use that as an excuse either. Because by the time I went and did my own observations, then I realized once you go down to the south and you watch the sun, there's no other explanation for the sun. Like, that's the sun. It's the sun. You can believe in the flat earth bullshit that it's apparent. There's no second sun. Now, oh, what about Crow? Yeah, okay. There's a sun and then one right next to it. In the flat earth, when the sun is south of me in Antarctica, it's actually 30,000 miles away behind me on top of Australia. So anybody who's still a flat earther just has a refusal to deal with reality, which tells us the shape of the earth. Now, I get it. I was there. I was there with you. And it took a trip, and it took me really thinking about it and understanding what I was seeing. And I think I even remember in Antarctica not believing at the time, like, I'm not really understanding what I was seeing. Like, okay, I can still explain this. I could still get it. But then I just kept thinking, and those nights in Antarctica and on the flight back, it hit me like, there is no explaining that. There is no explaining the sun south of us in Australia. I mean, in Antarctica. And like, I started to think, well, could we be wrong with no, how could you be wrong with the directions? It's the sun made a circle around you. In fact, it doesn't matter which direction it was, right? Like, the sun does a circle around you. So what difference does it make what direction? Now, granted, you can tell by the tilt when it's high. And if there was no tilt, guess where you're at? Guess where you're at? You're at the South Pole. There's only two places on Earth where the sun doesn't change its elevation all day as it goes around you. South Pole, North Pole. That's it. So if you're ever at a place when you look up at the sun and it circles you for 24 hours and it stays at the exact same height, you're at one of the poles. And if you're at one of the poles, as Sam said from Flat Earth Reconnaissance, if the Earth has a North and South Pole, then it's a globe. And he's absolutely right. And there is a South Pole. How do we know that? There's a South Celestial Pole. And there's a North Celestial Pole. What's below it? Everybody agrees it's the North Pole, even though none of you have been there. So again, if you have to see something to believe it, then don't believe in the North Pole either. But the problem is you are flat earthers, so you believe anything that matches your belief and not anything against it. That's the problem. So you believe that nobody's even questioning whether the North Pole is below the North Celestial Pole. Why not? Because it matches the model that you want to be true. That's why. So you're questioning the things that are making your model false. Again, I showed you on a flat earth map, the South Pole is everywhere. If you think that that's reality, if you don't think that people have been there, you can probably find people in your family or in your life that have been to the South Pole. And if you did, they're not going to tell you that, oh yeah, well, there must be an infinite amount of those places. An infinite amount, like at least a couple thousand is the only way it would work. Again, you can get to the South Pole in 5 hours from South America, in 6 hours from South Africa, and in 7 hours from Australia. They all convert. That's impossible on any. I want you to think right now, if you're a flat earther, just think for me. Picture where you're at right now in your house. Now I want you to picture that you think that the world goes off in all directions around you straight forever. Think about that. Start picturing going away from you in every direction. The earth goes away from you and never converges again. It just goes away from you. And then picture at the very outskirts of to your right and to your left and to in front of you are 3 continents. And that those continents, if you went to those continents and then tried to get to one location, from all those locations in 5, 6, 7 hours, you would hopefully realize, oh, what I'm thinking of is impossible. How could 3 people at the far out stretches, think how far 100 miles is, think how far 1,000 miles is. Now picture in that direction 8,000 miles, and in that direction 8,000 miles, and in that direction 8,000 miles. And now remember that those people at those tips can all get to one place in 6, 7, and 8 hours, or 5, 6, 7 hours. It's literally impossible. Literally. The earth cannot be flat. It will never be flat. Flat Earth has provided 0 to the world. 0. You have less friends than you had when you weren't a flat earther. You have less money. You have a worse job. Nobody is improving their lives. Nobody's getting better. Nobody's learning anything. Nobody's a better person. You're all worse people. You all threw me under the bus in a fucking heartbeat because I came back and told you the truth. You're terrible human beings. Terrible. The messages I get I could show you 50 messages that are death threats. Have you gotten death threats for telling the truth? I did. So fuck those people. They are not good people. I used to think Flat Earth made you good people. It does not. It makes you a worse person. It makes you start doubting everything. Truthers in this world don't know the truth about anything. They don't believe in truth. We'll never know. We can't know anything. Okay, great. Then just believe you can't know anything. Great. But then don't get into scientific debates. You don't have a model. You don't have a map. You don't make predictions. Therefore, you're not involved in science. You're involved in religion, which is fine by me. If you want to be a religious flat earther, great. But you don't need to make death threats at me because I don't believe in your religion. Sorry indeed. And you all believe me. As an example, you all believed everything I said when I was a flat earther. Now you believe nothing I said as a globe earther. You don't see the problem with that? You only believed me because I was telling you what you wanted to hear. It should be obvious. You should go, oh, that's weird. When Jaron was on our side, we liked everything he said. Now when he goes on the other side, we don't listen to anything he said. We think he's a sellout. Right. So if that's the case, then do you realize you'll never not be a flat earther? Because how is somebody going to bring you any information that goes against what you believe? It's impossible. As soon as they do, you call them a shill and say that they faked their trip. I mean, people like, have you seen this stupid flying skier thing? I had 2 people message me on Facebook yesterday that said, hey, sell out, shill, piece of shit, garbage. The flying skier is going to be the death of you. I'm like, flying skier? What the fuck's this guy talking about? I just ignore it. Got another one, same thing. I'm like, what the fuck is a flying skier? What are these guys talking about? Then I see today, Dave McKeegan makes a video and says that Vlad and those guys thought that they found some flying skier and it was just a flag. It's like, because these guys are so stupid, they went to the video that Dave presented on my show, which is like 3 times removed, and they're why don't you go fucking ask for the original film? How many times do we have to tell you that? Stop using YouTube downloaded garbage and making assessments of it. Dave was skipping through the video on my show, skipping through it. And you guys took one frame and said, oh, look, there's a skying flea. No, go look at the video. Now Dave put it on his channel, by the way. You can go to his channel. He has the entire 45-minute video of Tune on that motor or on that ski or whatever he's on. What's it called? Skidoo, whatever. But when you look at that and you look at the real footage, you see that it's just a flag going by. And these guys are all like, oh, sell out, shill, garbage human. This flying skier will be the death of you. You are retards. RETARDSs. That's what you are. Okay? To come at me, to throw somebody on the bus, to be that way to another human being, and you end up being wrong. Do you think I've gotten any apologies? Do you think? No, not one. And I don't expect them from terrible, shitty people. So I'm not surprised. So I don't expect any apologies when all you people realize over the next 5, 10, 15 years how wrong you are. Because the earth will never turn up to be flat. There'll never be evidence that it turns out, oh, it is flat. Impossible. It's impossible. And I hate to be the one to tell you because you're like, well, you were so wrong. Now you want us to expect to know that you're right. Well, sometimes you're wrong because you believe a certain way. And then when you see that you were wrong and then you go look, then yes, you can realize that you're right now. Sorry. I get it. You don't have to listen to me. Go do your own research. Go down to Punta Arenas, December 14th. Watch the sunset. You don't have to go to Antarctica. You'll see it for yourself. Go watch the South Celestial Pole. How could we have on Earth 2 poles turning in opposite directions perfectly like that? And then the globe says, oh, that's exactly what you'll see. And it's not like they just say that. You can go look at a globe model, bring up Andrew Marsh's model. That was the clincher for me. Do you know that everybody on the same longitude, same latitude has the same exact time of day? Like things like that just make no sense otherwise. And if you go 6 months later in the opposite, so it's 35 degrees north and then you go 35 degrees south, 6 months later, they are exactly the same. If you look at a flat map, that doesn't work. Do you understand that the sun has to heat up way more area out in the south? How could it be that those places aren't way colder? The sun's moving like 3 times as fast. So the sun in the north hangs up above there. Okay, great. In the south, it has to move way faster. So those places should be freezing cold out there. They're not. Australia's not freezing cold. It's the same temperature as 35 degrees north, where I live. Me and Australia basically have the same weather. Okay. So no matter how many times you try and poke a stick at it, you're going to figure out that the globe, as crazy as it is, as insane as it is the truth. So if you are a truther, then you'll believe in the globe. If you are a flat earth religitard, you will believe in the flat earth. I was a flat earth religitard for 10 years. I can admit that. Oh, well, guess what? Sometimes you're wrong. You stand up and you say, oh, I was wrong. My bad. Now I'm right. That's it. You get over it. You don't cry yourself to sleep. You don't throw people under the bus. You don't tell people death threats. You don't call them sellouts and a bunch of bullshit with no evidence at all. Zero evidence at all. But you know who does? Flat earthers, because they don't care about real evidence. They care about whatever makes them feel good at night, whatever makes them sleep good. And I know what happened to all you because it happened to me. The difference is now I just have no friends. I get it. You are looking around. You're like, oh shit, I told off my family. I told off my friends. I told off everybody. I said how much smarter I was than them. So now if I'm wrong, that means I'm not smarter than them. And it means I have to go and apologize to every one of them. And I have no more YouTube career and I have no more YouTube family. That's what you have to do. Now, I get it. All you guys are too pussy to do that. You don't have balls enough to stand up and say, you know what? I got to be real with myself and with my audience. You would rather just be there in the comfort of all the good flat earthers and go watch more Vlad stuff and, you know, whatever his name is, Flatzoid. Good for you. If you haven't realized, go look at the numbers of views on flat earth videos. The flat earth is going away. Okay? And I'd like to take some credit for that. Going away because it's wrong and needs to be put away. I got into flat earth because I thought they were lying and indoctrinating my children. Guess what I found out? We are the ones that were lying to children. You, if you're a flat earther, are lying to your children. Stop it. They're going to be worse off in the world because of you. Thank God I figured out what I did when my son was only 4. Never learned anything about that. And I'll tell you right now, he's got space jammies. Okay? And I'm okay with that. They're cheaper than the other jammies because they got no name brand on them. You know, you can have Saturn jammies and they're cheaper. So guess what? He's in space jammies and he loves them. And that's just the way it goes. And he's better off than if I told him, oh, here's this flat earth map. And yeah, it just so happens at the outer edge of the circle, Mavi, it's all the same place. All the outside of the circle, the same place. How we don't know. It's just, you know, random suns. What about that sun? Nah, we don't know if that's a real sun. Could be over there too. Could be above Australia. Who gives a fuck? Who knows? I don't know. Do you know? Nobody does. I love you guys, and I got to get to bed. Much love. Oh, it's 9 o'clock? What the hell's wrong with me? I thought it was like 11. Tomorrow I'm going to be on with Culture Cats, but I think it's recorded. And then wait, I have something else though. There's well, let me look at my calendar real quick. I know there's some. Oh, my phone's dead. That won't work. All right. Somebody say great job today. Thank you very much. Big Fish, nice to see you. Big ups, Roger. Nice to see you. Monkey Cat Pat in the house. Cheers all. Jaron, some space jammies are flat though. Yeah, they're when you might earn them and stuff. They're flat. Scared of Eric Dubay. Eric Dubay will not debate anybody. The guy, so funny, these guys. Like I did for 10 years, like 9 hours of weekly live content. Eric Dubay's never done one. And you guys are like, yeah, you're afraid to debate. Yeah, Eric Dubay is not afraid of anything, considering he won't even get on a live stream with anybody. Yeah, you're right. Yeah, good point. You guys are so smart. The good thing is I no longer expect anything smart to come out of any flat earther's mouth. So I'm not surprised when it comes out. I'm like, oh, there's another dumbass shit. Thank you very much. Fact Down's tomorrow. Thank you very much, Megs. Appreciate that. Fact Down at 3 p.m. So 3:30 we start. 3:33 actually. 3:33. And you just, if you want to join us, 15 to 33 questions right, and you get to put on the wheel. You get a chance at winning the money, and that's going to be tomorrow at 3. And I've got Culture Cats in the afternoon. Jaron, when are you going to stop believing in the Cookie Monster? When are you going to stop believing? No, Cookie Monster. I don't think he's real. Well, I might have to look into for evidence of that one. We got Fact on tomorrow. Yes, thank you. Fresh home from Dubay 101 camp. Eric Dubay is dumb as rocks. Well, he certainly is a flip-flopper, right? Like the rest of the flat earthers. I mean, really, you know how many people said before the 24-hour sun? Of course, they just lie now, but they all said before the 24-hour sun would be a problem. From Sov to Dave Weiss to Witsit to, you know, you name it. They all knew that, and they just all have changed, and you guys don't care. This is the thing. They know that you don't care, that you care about the religion of flat earth. So there's no rhyme or reason. It doesn't matter why they decided to just stay on flat earth. Like, you'll literally let Dave Weiss make shit up like that we can put plasma balls in the sky that emulate the sun, that have the same sunspots that Melodome filmed from California, or I mean from Florida. That's what you believe. Here's the funny thing about flat earthers, and I think it's hilarious. You guys believe that I could do the impossible. It's literally like Fort Knox got robbed and 3,000 pounds of gold went missing, and it was gone in a matter of 4 minutes. 3,000 pounds are gone, and I'm there on my bike, and then you guys are like, Jaron did it. Like, me? No, I'm just driving by. You're like, no, we know that you took that gold. Like, where, how would I take the gold? You're like, you took that 3,000 pounds of gold on your bike. I took 3,000 pounds of gold on my bicycle? Yep. That's what the equivalent of you guys thinking we faked Antarctica. We couldn't fake Antarctica if you tried. You wouldn't be able to do that with a huge ass budget. But you guys aren't smart enough to realize that. You'd rather give us the power that we faked Antarctica because you saw a flying skier, which ended up being a flag. Now, will flat earthers admit they were wrong about that? Probably not. Because they just don't have it. There's no interest in that. In a real world, people should stop following you when you keep being wrong. That's not how this works. Not how it works. You can be wrong. Dave Weiss can be wrong all he wants. He's lied to you guys and told you that he didn't set up the debate with Will and me and Austin. I have the text messages. That's exactly how it was set up. And I didn't know that Dave went behind my back and talked to Duffy on the phone. I didn't even know that. Thanks for that coming out. I had no idea because I thought Dave was being honest. Dave is not honest. He's a liar. And whether or not he admits that, it just means he's going senile. It means that he now is, what did I got the name of it. He's a mythomaniac. Okay, a mythomaniac is somebody who believes their own lies to the point that they think they are the truth. That's Dave Weiss. He lied so much about that interaction that now he believes he's never talked to Duffy. But he's been on the phone with him and it's been recorded, which is just hilarious. He's just a liar. And you guys let him get away with it and you'll just keep, well, I guess Vlad doesn't and Sam doesn't. So at least some people are starting to call him out because, yeah, he didn't care when he leaked my data, my address. He didn't give a shit. He didn't care. I was like, well, I'm going to have to move now. He's like, well, that's on you. If you leaked my address and then I say I have to move, then for you to say that's on me doesn't make a lot of sense to me. What's on me? You leaked. Now I have to move because of what you did. No, it's on you. Okay. So if I punch you in the face and break your nose, you're like, I got to go to the emergency room now and fix my nose. No, that's on you. That's on you. What do you mean? You punched me in the nose? That doesn't matter what I did. You're choosing to go to the emergency room. That's on you. Yeah, but you broke my nose. I don't care. It doesn't matter to me. It's up to you. You get to do what you want with your life. And I hear Dave tell people, oh, we invite whatever happens to our life. We invite it onto ourselves. Okay, Dave. Oh, boy. There's no redeeming qualities left in the flat earth. There's no good show. There's no actual real conversation about anything that's important. It's people arguing over a trip that clearly happened, that anybody should know happened. You can go look at my channel and look at me live stream every single day. We have got 7 cameras going at the same time. Do you realize how impossible it would be to fake what we did? I flew in on an airplane and landed on the fucking ice. Do you understand that? How did that get faked? But again, flat earthers would rather believe the impossible and call me every name in the book than to ever for 1 second think that they might be wrong. Guess what, guys? You are wrong. We were wrong. Period. The shape of the earth can be figured out. And you can do it yourself, but you have to choose to be open to different possibilities. Now, there's no flat earther that doesn't think that they're right. That's the problem. So now again, here's the problem with the globe earthers. They're the same way. The difference is they're right. Do you understand? I'm not saying that the globe believers are doing it right. They're not. They also have a confirmation bias, but they're right. So they get away with that because maybe they know more than we think, or maybe they figured it out in another way, whatever. But regardless, you are wrong. And so if you try and tell me, well, the globers, no, it doesn't matter. You're wrong. So the only way you're ever going to figure that out is to test things on your own, to look at what people say, to challenge what they say. Do not listen to a flat earther say, I saw this over this distance and I shouldn't have seen it. They all say that. They're all lying. They're all lying. Okay? Because if you go and actually look at it yourself, you'll realize they're wrong. That's why you have to ask them. I had somebody tell me the other day, oh, I can see this shore from 20 miles away. I'm like, you cannot see a shore from 20 miles away. Stop being a liar. Oh, yes, I can. What, do you call me a liar? Yeah. Why don't you go take a picture? Oh, I got to take a picture for you? Yes, you do. Because you cannot see shores from 20 miles away. Period. I've went to Monterey Bay many times. I couldn't see the shore. Kidding me? So, again, you need to listen to what people say and then actually challenge it. And here's the problem. Nobody challenges anything on the flat earth or on the truth or sphere. I saw everybody talking about, oh, that movie, Snake Eyes came out September 10th and same date as Charlie Kirk. No, it ended up being September 19th. Wasn't even true. Oh, the guy that killed him's name is Tyler. Nope, not true. It was the guy's name. The boxer was Tyler. So you guys, and you just believe it. You just buy it all. You just buy it all. And then when you find out that you're wrong, you just move on to the next topic. It's like dopamine hits for you. It's like your crack cocaine. Tell me something else is a lie. Tell me something else is a lie. I'll smoke that too. Tell me something else is a lie. Tell me. I love lies. Lies are great. That's what you guys are. You get off on hearing that things are lies and that the world is a lie because it makes you feel better about your shitty life. I get it. I understand shitty life. I have to get back to work and I have no friends. But you know what? I've got integrity and I've got truth on my side, and that's all that matters to me. And I don't give a fuck about losing friends who are human garbage, which most of flat earthers are. Much love to you guys. We'll see you again soon. Until then, this has been Jeranism. Remind you to do your own research. When you do, you'll never again believe that you can't tell the shape of the ground by looking at the lights in the sky. Guess what? You can. And I lost my outro. Guess you don't get one. Unless, nope, that's not it either. I lost my, I could just play the intro again. Did you guys like the intro song? I liked it. It's good. We'll just play that again. We'll do that. We shall do that. But again, I know that me yelling at you is not going to change your mind either. So there's just no way to get at it. No matter how nice you try and talk to somebody, no matter how mean you get to somebody, if that person has a brain like I had, there's just no getting through it until you start to doubt yourself and you say, okay, let's pretend I could be wrong. Flat earthers have never thought that. I had to think that to go to Antarctica. I had to think to myself, like, okay, what does it mean if I'm wrong about this? And then you start to break down what you consider to be your belief. But if you never think you're wrong, if you're so cocky that you think you're smarter than every single physics professor in the world, then you might want to look at yourself. Think, I didn't graduate high school, and I think I'm smarter than every physics professor in the world who has not figured out the trick that I have, that the Earth's actually flat, even though it doesn't work in anything. And even though it's brought nothing to the world in 10 years. We brought nothing. We improved nothing. We invented nothing. So you think that's the truth? You think the truth doesn't improve on the lie at all? What do we get? Are planes faster now because of flat Earth? Did we figure out different plane routes? No, nothing. Nothing at all. It's just a bunch of people who don't know what they're talking about, me included, who went around and because of a couple different lines of evidence, then took that to mean that the South was a lie. And from there, you can construct whatever you want. I just knew that the South had to be a lie. That's the only way I could construct a flat Earth. Once I realized the South is exactly what we're taught, there is no more question. The Earth is most certainly not flat. Much love, guys. Peace.
My wallet's broke, but the globe came through. I ain't rich, I'm just rich in proof. Y'all still spinning circles trying to find the roof. I'm living rent free all up in your head. If I make a post, y'all start seeing red. You brag, you gifted, you all so smart. World views held together with duct tape and farts. The yellies compromise while scratching their ass. Never left their mama's house, begging for cash. Say I fake Antarctica, bro, please hush. You ain't even been outside since Candy Crush. Under the bus, they roll me flat, but I bounce right up like who's laughing at that? You can keep your maps and your comment threads. I got photos, sunspots, and 310s in my bed. Under bus, they screaming shield, but if selling out paid out, I'd have paid my bills. Call me a traitor saying that I'm a fake. You have no map and no model, for fuck's sake. They said he's a Freemason, reptile clone. Bro, I can't even get a payday loan. I'm broke as hell and I rent my home. Lost my views, you lost your mind over a drone under dub. They threw me twice, but I'm still that dude who think precise. You can mean me, scream me, call me fake, but I'm the only one out here showing the way. They threw me under the bus, but I dusted off fine. I seen the South Sun circle, y'all still stuck online. 10 years deep, I questioned it all, but y'all can't admit we went over that wall. I packed my bags, hit the edge of the map. You stay home making memes and talking crap. You don't do research, you just parrot Dave and Crew. Didn't I tell you to never trust a dude? What? Saying he's a sellout, he's a shill, he's fake. Bro, your best researchers got stuck on Vape Gate. You think I'm compromised? Nah, I'm free. You're the one in chains mentally. Dave White says, yeah, he must be compromised. He's got an app to sell, I'm sure he never tells lies. Didn't give a shit when he licked my data on his app. He was probably on vacation, taking a nap. I took the L, learned, evolved, but y'all still mad, think the problem's unsolved. You don't need evidence, just vibes. Y'all think you can stop me from changing my mind. They can't face it, so they hate it. Truth's too heavy, so they fake it. I went south, they stayed blind. Now they rage online, stuck on rewind. They can't face it, so they hate it. They call it lies, so they can't debate it. They'd rather call me alive and admit they're wrong. Cold mind's weak, but my will's still strong. I saw the ice, I saw the glow, the 24-hour sun put on a show. They call that fake, say it's CGI. Why it thinks they can shoot a plasma ball up in the sky. I'm at the cold, I saw the stars opposite spin. They've never left the house, they're trapped within. I found peace and evidence and proof. They found comfort in denial and goof. They yell, he's bought, he's part of the plan. But my bank says different, I'm still the same man. They call it selling out, nah, it's called growing. But your echo chamber won't allow you to be knowing. 10 years strong, I held the belief. Then I'm at the South Pole, brought me relief. Now they call me Judas, traitor, thief, but at least I left the code. Easy there, chief. Lad wants to see my ticket. Well, black and suck a dick. He's as dumb as rocks, and rocks had little pricks if they pranced around wearing robes. So scared of the truth became Antarctica phobes. They can't face it, so they hate it. Truth's too heavy, so they fake it. I went south, they stayed blind. Now they rage online, stuck on rewind. They can't face it, so they hate it. They I stay fraud, but I saw the globe with my own damn eyes. God, don't twist your words, edit your clips. Lose another job and lose another relationship. They ain't signing tips, the scared kids lost. Every fact to them feels like a cross. They don't want truth, they want belief. Faith in fear, disguised as relief. But me, I took the heat, I took the fall. I faced the facts, I stood tall. Hey, I'd rather burn in your digital hell than lie to myself just to sell a sale. So keep my name in your live stream fights while I sleep comfy every fucking night. You can't undo what I seen firsthand. Truth ain't flat, that's fact. It's a globe, my man, and I do it again just to prove what's real. Cause I don't kneel to your cultish feel. They can't face it, so they hate it. Truth's too heavy, so they fake it. I went south, they stayed blind. Now they rage online, stuck on rewind. They can't face it, so they hate it. They call it lies, funny I debate it. They'd rather block me and mock me than admit they're wrong. You're limp and weak while I'm hard and strong. In law, now what's the end of the scene? That was the end of the